EU-India WaterTech Event. Yesterday we had wonderful presentations by all the projects, and today we are proceeding with the theme of lab to market, market access and opportunities in all those projects. So we will begin today's session with the opening remarks from Dr. Praveen Kumar S., Head Technology Missions Division, TST. I'd like to request Dr. Praveen to please come on dais and give an opening remark to our audience.
Very good morning to all. Yesterday we had a very fruitful, I feel that it's a very fruitful discussion, and wherein the 7 projects, in fact, culminated out of a collaborative effort between India and EU. We have seen the kind of output from these 7 projects. And but the big question is that what is the way ahead? So we are all keen to listen how these 7 projects and also associated technologies have flown out of lab to the market, and what is its readiness index to move ahead. So I welcome all those who have participated here as well as on online to positively contribute to this, I should say that a common cause between India and EU partnering entities. So it's a really a delightful opportunity to listen what has come out, what is our preparedness for the next level of engagement. And I thank the DST expert committee, the DBT expert committee, and also the EU counterparts to steer this program. And once again, I am welcoming all those to this wonderful platform, which in fact to take you to different levels after this session. That's what my hope, and thank you. Yeah.
Moving ahead, I would like to invite Dr. Manoranjan Mohanty, Advisor, Office of PSA, Government of India, to give a brief opening remarks for this day of the event.
Thank you. Sorry. Good morning to all of you, those who are in this hall as well as those who are online. So what Dr. Praveen said, of course, we had a very good discussion and deliberations yesterday. But before we move further and proceed in this today, I'd like to give a brief maybe note of what is TTC, because where actually we want to identify rather some of those technologies and innovations that have come out of this India-EU partnership program. So for you all, the India-EU strategy, India-EU TTC, Trade and Technology Council, is a strategic coordination of and engagement between India and European Union. And it was formally announced on 25th April 2022. And it was launched on 6th February 2023. And the aim of this is to have a strategic engagement between India and EU in the to promote trade and technologies in this direction. Within the framework of TTC, we have actually 3 groups. And just to give a brief account of that, working group 1, 2, and 3, Working group 1 is on strategic technologies, digital governance and digital connectivity, chaired by Minister of Electronics and Technology from Indian side also, and European side, chaired by Working group 2, which is actually we are dealing with, that is on green and clean energy technologies. And from Indian side, it's chaired by Principal Scientific Advisor to Government of India, Professor Sud, and from European Union side, DG R&I, Mark Lemaitre. So, and the working group 3 is trade and investment. So, to give the brief account of, again, the terms of reference is that, we have to identify certain technologies that is on green technologies and clean technologies, including working on investment and standards, and with emphasis on research and innovation. And then we have to identify the niche areas of mutual interest for collaboration and implementation of clean energy, waste management, circular economy, plastic litter innovation. Then cooperation between EU and Indian incubators, SMEs, startups working in these areas. And of course, at last but not the least, the building human resource capability and capacity in such technologies. So there are a few meetings already taken place. The first ministerial meeting that was held in Brussels when Dr. Tanya was there also. And there actually we defined and developed the roadmap for the working group 2. Of course, it was developed for all other groups too. Since we are involved in, me and Dr. Tanya, we are involved in working group 2. So we have developed and adopted the work plan on for this working group 2. And in this work plan, actually, we have some actions, and one of the important area is the wastewater treatment and management, plastic litter innovation. This is action 1. So in this, we could find that the technologies that are developed through this India-European water partnership, they have the potential to take it further. Maybe TTC can provide the platform for that. So, since it is one of our work plan, and we want to take this opportunity of this partnership and emphasize some of those important areas that are really required for both the sides. During yesterday's presentation, we came across, varieties of technology, in the that were developed in this India-EU water partnership. From the 7 projects, we witnessed, areas ranging from clean water, wastewater treatments, then irrigation water also, and many other things. Some of those technologies are in the range of tier level 6 to 9. So, which is good actually. We are expecting, because 6 months ago when I was going through those documents, I could find most of them were in tier level 5, because that was provided by Dr. Tanya. Then I realized yesterday when I attended the meeting and listened to the deliberations and presentation from the PIs, I could see that they have really gone way ahead actually what we have thought earlier. So, so from these projects, actually, I have noted a few points, what I observed yesterday. Some of the projects, having pilots that in verification stage. Some are already ready for market, for commercialization, because when we say that there are tier level 9, then that means they are ready for market uptake. And some require some more time to get matured as technology is for the market. Having said that, it is important to know how these technologies are different from the already available technology in the market. That Dr. Prasad also told yesterday. I remember that also. And what are those niche areas they have captured? That means all the PIs they have captured through the collaboration, so as to get noticed in the market, as well as meet the demand of the stakeholders for which they are intended. So most importantly, the developed technologies should meet the standards of Indian standard, definitely set up by CPCB or maybe NGT, because they have to compliance the regulatory mechanism for India, so that they get into the Indian market. So today we are definitely going to have, I think eventful day where we'll see that, presentation by each PIs again to showcase their technologies, they're ready for market. And since I am having 2 more sessions to go, I don't want to discuss more about or talk about more. So I am looking forward to the presentations as well as the deliberations, and accordingly, we'll see that how many technologies they're actually ready for the market based on the presentation by the PIs. So thank you very much, and thank you for the opportunity to be here and discuss about TTC. Thank you.
Thank you, Dr. Mohanty, for your remarks on several opportunities. Now I'd like to invite Ms. Tania Friedrich, Senior Policy Officer, International Cooperation, European Commission, to give an opening remark.
Good morning, everybody. And I think that on behalf of everybody, I would first like to start with thanking Professor Madhu for the lovely dinner we had last night. Lovely setting, lovely food, allowing to meet with all the people, learn even more about these technologies. And waking up on this campus is really a treat with the nice lights, the trees, and it went through my mind, I wish I was a student here on this campus, but that is not the case. So back to my role as official of the European Commission, and thank you, Dr. Mohanty, for having explained and put the context of the Trade and Technology Council, TTC. We do mention it from time to time, but it is true that it is not yet so familiar with many of us what the Trade and Technology Council is, but you can get a little bit the gist already from the title, Trade and Technology. EU and India, we are strategic partners, and it was both the Prime Minister Modi and the President of the Commission, of the European Commission, Ursula von der Leyen, who said that we need to strengthen that partnership. And how better can we do that than through technology? So I think the first thing we can say, are we not important? Because what are we all doing is developing these technologies. And they're not developed for the sake of it. They are developed for to speed up the greening transition and the digitalization. And that's how we came to this different working groups. We are in working group 2 that focuses on green technologies and clean energy technologies. And you can do that within these topics. Again, the focus is science and technology, because what have we established is that through increased efforts on research and innovation, thanks to, again, scientists and innovators, we will understand each other better, and we will also create products, technologies that are fit for the global market. What we want to do is that speeding up the transition to a green economy, to net zero, to both the EU and India are committed, we need to increase the capacity of the renewable energy. We need to have the technologies ready, but we cannot do it all along. The challenges are big. And if we have seen how big the challenges is, it is certainly in the water challenge. And yesterday, indeed, we had a very interesting day. We especially, and this is also something that we shared last night, like for me, we're not a scientist, and therefore it is quite impressive with how many ideas and technologies that you have come up. And I think that in itself deserves kind of what we have said today, from the lab to the market. Maybe, I don't know if we could say in India, from the lab to the mela. but it's so I really have high expectations on today that all what you have developed in the last years, that you can present that not to us. We are, as public administration, a step back today. The jury is out by the industry that we have invited, by others that have more experience and expertise in assessing technologies in their marketability. Because we have heard yesterday also, as you said, that we are in very high TRL levels, which is fantastic, which was again beyond expectation. We are at 6, at 7, at 8, and some are well, not yet there at 9. So that's why we also are here today for this last mile to the market. And it's this last mile, is this extra mile, is very, very difficult. And that's why, as we said yesterday, we don't want to let go. So we are also there if we identify today that your technology makes the test to the market, that the industry is interested, that it has a purpose, that it has a potential to be rolled out, we are very open to look at what is necessary to make it happen. Because what we don't want, compared to a robust cooperation on water that we have had, is that all this technology, all this know-how remains in the shelves. It has to be applied, it has to be transferred, it has to be rolled out in India, and there is scope for that. And that is what we are here today. So we want to see it together with industry, together with many experts that are here in upscaling technology. We want to hear if you have already attempted to do that, and if you have experienced difficulties doing that. We're also there to take note and to see together in this Trade and Technology Council how we can address that. But of course, we also hope that we can have a couple of success stories where we say what we have said in the beginning, that through increased efforts on research and innovation between the EU and India, we can reach the market. And we have created a product that is adaptable, that is affordable, and that is compatible to be rolled out. So like you all, let's start. And we're looking forward to hear now in a different mode than that we heard yesterday, what you want to present, what you want to have ready for the market or on the market. And be reassured that we, especially from the European Commission, we have envisaged some further support if that is requested, if it is in technological assessment, in market penetration, in research on the market study, or on the right methodology or business model to use. But let's first hear what you have, and we can later throughout the day discuss in a very interesting session that Bertrand will moderate on understanding a little bit the ecosystem and from both sides, and what are the bottlenecks. And later on, we will then also share with you how we are there to also help and committed to address these bottlenecks together. Thank you very much for your attention, and very much looking forward to the pitching finally.
With this, I thank all the speakers for setting up the floor for today's theme, Lab to Market. Moving ahead, we would like to invite Professor Rajendra Prasad and Professor Chanakya for giving us summary comments of yesterday's projects and their comments on the projects.
Good morning to all of you. It's really a pleasure. And then I feel it a privilege to place before you the achievements that we have made in the last 4 years. Maybe some of them also had a backing even prior to that. And I think, as all of you know, that we have about 7 projects supported in India by the European Union, and that's a collaborative program between India and European Union, and 4 of them by the Department of Science and Technology, and the rest of the 3 are by the Department of Biotechnology. So if we really look into these particular technologies, and more so those, the entrepreneurs who could not make it yesterday, I think this gist of what has really transpired would also help them to see whether they can put their foot into it and then make sure that they'll be able to get something out of it. So there are one of the projects which was known as Lotus. Its main focus is on the development of a multi-parametric sensor or multi-element sensor, which will be utilized in the water management and water distribution systems. That is one of the things and this should really help in optimizing the resource, because water is becoming more and more scarce and its requirements are increasing day by day. So in the context of that, this sensor trying to provide the real-time data and then also data enough to make sure that the monitoring and the management can be done on real-time basis. So from that point of view, this technology has this is a joint work that has been done by European Union, and the basic technology was transferred from the European Union to India. And this sensor is one of the major issues that has been come up, and then they would like to implement it. At this stage, a little more work is yet to be done to really make sure that about the robustness of the sensor and the scope for adding more and more elements. The scope is already very well defined, but the only thing is a little more work has to be done in that direction also. So this, and they would be utilizing it in in urban areas, in the water network systems, and in areas where in peri-urban and even in urban areas where we still depend on, in some cases, where the water is being fetched from a different place and delivered at the household level. So that's where you use the tankers for transportation, and then it requires a lot of scientific support to make sure that this tanker delivers the best output. And then the other thing is irrigation. As all of you know, that the irrigation is something which is a very major issue, and then in any part of the world, major quantity of the water gets into agriculture system as irrigation. And then this irrigational components, I think this sensor is also going to play a very critical role. And then this is what it is being, that's the major issue of it. And as a part of it, a number of technologies, number of software packages have been developed to make sure that automation is in place without much trouble. Coming to Pani Water, there's another project it focuses on the treatment of emerging contaminants. And these emerging contaminants, they also deal with both freshwater as well as wastewater treatment. So this particular technology, this Pani Water program, has come up with the technology known as FAU, filtration, adsorption, and UV treatment. So this has really worked out to be extremely well. This is very cost effective, and the results are very good, which will deal with pathogens, which will deal with other microbial components. And then for drinking water, this is supposed to be the very best technology. The only thing that we are really looking at is how much we can really make it competitive with the local market as far as the cost is concerned. Technology-wise, it has got a lot of advantages, but that has been already established, and the other part is ready. The other one is MFR. It's a multifunctional reactor, which again, the technology has come from the European Union. And then there's another multifunctional reactor, where the entire technology is from India. And then both of them have been very well tested. And then that also needs, I think it's also ready to go into the market. And then maybe some logistics have to be really worked out. There was another technology that jerry can, it's not really a technology, a container, which can really treat the pathogens and some of these things. But unfortunately, the materials that can withstand or sustain for the local tropical conditions and the climatic conditions is still, maybe I would say we could not succeed completely, but it has been in a very good shape. But that is something which requires a little more work on it before it's being thought of being pressed into the market. Then we also have the EOD using different multiple electrodes. The treatment technologies have been done, and this particular part has been done very well in the laboratory, but it really needs a field validation, and which we feel in the next few months we should be able to get it ready. Now coming to Pavitra, there's another project which also has done a lot of work in the previous FP7 program. Something similar. They also deal with nature-based solutions as well as constructed wetlands as well as advanced technologies. They really take a combination of all these technologies and make sure that they really treat the wastewater for both reuse and then recycling. So out of these technologies, these electrochemical, electrochlorification, then anaerobic baffle reactors, ABRs, then the constructed wetlands, as I told you, SBR and rich water SBR, all these things, they also have a situation where they really try to retain these nutrients and still try to make use of this water for reuse and so on. So that's where I think it has got two advantages of treatment as well as trying to reduce the burden of trying to utilize more fertilizers and all that. So that's one component. They also looked into the component of rainwater harvesting. India has done a lot of work on rainwater harvesting, but the technology that has been brought in now into this particular program has got technically a lot of advantages, but the maintenance problems, etc., and the cost analysis still needs to be really grounded and make sure that it can be implemented. That's the only thing. But technology-wise, it's very good. Absolutely, there's no problem at all. Now coming to and there's another SAF technology, which is aerobic fixed film reactor systems and so on, and oxidation. All these become a part of Pavitra. And in Pavitra, one of the big advantages that we have really taken up is 1 or 2 or 3 technologies have been clubbed together, make sure that the results are good. But adding these technologies did not really increase the cost of it. That's the biggest advantage that could be seen in Pavitra. Now coming to Saraswati, this is also a program which also had its footprint in the previous system in the FP7 programs as well as now. And then they also have USB reactors, SBR, then anaerobic, but it's all mostly focusing on the nature-based solutions. So the nature-based solutions, technology-wise, things have been proved to be extremely good, and cost-wise also, they have proved it to be really good. The only thing that we really should make sure is, can we really reduce the footprint on this? That's another thing which can be taken up in the near future. So as far as these technologies are concerned, all the technologies that can be technology, then, sand filter and UV putting it together. So then these technologies have been really good. Ion exchange process also was done in a bioreactor. So these technologies, when I say that they have been established, I can say almost they are market ready. Though in numbers, some of them were defined at TRL7, TRL8, and TRL9. I can say that the TRL7 ones are also needs only a little bit of refinement and polishing, and they're almost ready for market intake and replication in larger areas and so on. And in many cases, the scaling also was one of the constraints where the TRLs were put at a lower level. The scaling was not being taken up to the extent that is being required. So that also has the small constraint of putting the TRL levels at lower than that. So I would say that most of these technologies in general that has been defined and developed in this particular program, they are well tested. And I can assure the market people who are interested in this can really make something really good out of it. So this is what has been done from the 4 projects. Now I think I request my colleague, Professor Chanakya, to give a brief of the technologies that have been taken up under the other 3 programs. Thank you very much.
Thank you, Chair, and thank you, Professor Prasad. I'll continue where he has left, especially on the 3 projects supported by the Department of Biotechnology. The first one, India H2O, led by Professor Philip Davis from the European side and Dr. Anurag Mudgal from the Indian side.
Now, this project is posited in our coastal areas where, due to excess extraction of water, groundwater, there is saltwater ingress into the soil, and all the water resources have become saline. So it's a border between what do we do in this kind of a situation. And to this, our European partner has brought in an interesting one-stage RO kind of a system in which it's been benchmarked that they would achieve at least 75% of water recovery, fresh water, on the permeate side, and at a energy expense of about 0.4 kilowatt per kiloliter. Now, this would be roughly of the same kind of cost pattern as to recycling wastewater. And this leaves us with a problem. It gives us one is the water that is already saline, and it is also in tune with the kind of policy framework that's happening, that how do we make sure that we reuse the local domestic wastewater as well as industrial wastewater, and make sure that the freshwater sources are not polluted on the one side, and on the other side, we are bringing in more water into the total water budget. And so this meets that kind of a goal, and it's already the kind of policy support required for that, or a policy initiative is already there. And this leaves us with a problem of what do we do with the 25% rejects, which would be highly saline. And towards this, Professor Mudgal has taken up how do we grow a salt-tolerant species, which will have some kind of economic potential, that's Salicornia. And towards this, a lot of effort has been tried as to how do we work with potential users and make the overall picture something viable. The second project from on this side is Pavitra Ganga. That examines a whole bundle of how do we put in various forms of wastewater technologies into different locations. I'm sure you'll understand that India is a very large canvas, and something like Europe where we have different niches. So this project moves from the earlier horizon, or earlier pattern of looking at only wastewater treatment and moving into how do we do wastewater treatment along with recovery. And then, having done this, it's also important to see how do we bring it into the existing water governance system. So that being the second objective. And third, how do we monitor this so that it makes it very easy for businesses to run? How do we have some kind of a smart water management system? And this is driven by the fact that about 140 CECs has been detected in these waters. And therefore, there is a concern of how do we bring in different types of technologies and package them for various other applications as seen on the ground. They plan to put in about 14 such demonstrators. And I'm happy that they've chosen some of the toughest challenges. That one is the Barapula drain in Delhi, and other is the Jajnau in Kanpur. Now, if you solve these problems with the kind of technology package that you're thinking of, then you would more or less solve, it will work anywhere else in the country, because this is the toughest challenge that has been taken out. That is something very interesting. And of course, they're going in for how do we improve the resource recovery from the existing wastewater treatment systems, especially like the other projects on the DST. How do we bring back some kind of anaerobic treatment so that we conserve nutrients? And then how do we create a dashboard kind of a system in which we are monitoring in real time how do we the kind of treatment systems? And also they looked into what policy barriers are there, what policy windows are there, and therefore what opportunities for business comes in. This is an interesting area that these projects have addressed, and I'm sure they would now discuss, especially in the other earlier project, as to how do we deal with wastewater in saline areas, and in this also in specific locations, how do we open up policy windows where there's opportunities for business and getting into the newer forms of resource recovery. The last project is Spring, led by Professor Sanjukta Patra from IIT Guwahati and Dr. George Schneider from Hungary. Now, this looks into a real problem that we have in this part of the world. I'm sure it's there also in all other parts of the world, especially when we faced COVID. You have various forms of pollution in water bodies which have to be recorded in real-time basis. So what is the source of the pollutant? What are the types of treatment possible? And like in Europe and in India, we are now moving from a chemical-based treatment system to biological treatment systems. So this addresses that kind of a situation where situation where a problem has to be identified and appropriate solutions have to be provided. So towards this, what is interesting is the fact that the European partner is providing a both kind of a system in which the problem is going to be identified as to what is the type of pollutants that you are likely to find. And online, you also have a solution. You have what is a possible solution that you can move to. And that's provided by IIT Guwahati, where instead of chemical-based treatment, they're trying enzymatic-based in situ treatment. So they're addressing problems that are created by textile industry wastewater getting into water bodies, paper industry wastewater, pharma industry, and also some kind of antibiotic issues. So all these put together addresses a very real-time problem that how do we, once you detect some issue, how do we find a solution? How do you find an entrepreneur who will go there, identify what is the source of the pollutant, and give a right kind of a biological or an enzymatic kind of treatment. So all these three projects have very good opportunities for entrepreneurship and providing what we call real great exemplars for both Europe and India. Thank you.
Thank you, sir, for your summary comments. I would now like to invite Professor Ravi Godi to take the charge of the floor for proceeding the event.
Good morning again. Before we move to the next session, it's again a very pleasant responsibility, a very sweet moment, I would say, to honor someone who has been so passionate about research and innovation. And I would like to invite on stage Professor Prasad Perik, Dr. Abhishek and Dr. Praveen Somsundaram, please, onto the dais. Ladies and gentlemen, please put your hands together to honor Ms. Tania Frederick for her extensive contributions. I would like to ask Praveen to kindly escort Tania onto the stage, please. Yeah. Yeah. Manoranjan Mohanty as well, please. Yeah. Yes, we can invite both of you as well. Yeah. Yeah, I'd just like to read about Tania. Yeah. Tania is the head of sector for research and innovation at the EU delegation. She started this assignment at the beginning of September 2016. Before that, she was working in Brussels for the European Commission in the Directorate General of Research and Innovation Department for International Cooperation and was responsible for cooperation with the Western Balkan countries and Turkey. She has worked for more than 15 years on EU research and innovation policy. She was member of the private office of European Commissioner Philip Busquin for research and innovation from 1999 to 2004. Before that, she worked at the EU delegation in Geneva in Switzerland, following the negotiations on trade in services, GATS, under the World Trade Organization. She is a lawyer by training and obtained her law degree at the Universitat Brussels in Brussels, Belgium in 1980, and an LLM at the University of Michigan in Ann Arbor, US in 1981. Ladies and gentlemen, please join me in according a big round of applause to Ms. Tania Frederick. as she is being felicitated. I'd like to request Professor Prasad to kindly do the honors. Yeah.
I think I may be permitted to say a couple of words about Tanya.
Oh, no.
I said couple of words, only two. So now I think she's an exceptionally different personality when she really makes a real big balance between her personal training, professional traits, and individual humanity. And all through, she also keeps the nations behind her mind, what should be the best for those nations. I think this is a very peculiar combination where you really don't find so many combinations. And she is the person who was involved along with Sadhana Relia madam. These are the two ladies, because many times when we say that the lady is behind the success of many other things, so the Indo-European program, I would say these are the two ladies who are behind the success of this particular program, and a wonderful collaboration between India and EU. And she has such a, you can't really imagine. She used to work even at 3:30, 4 o'clock early in the morning to make sure that the projects have come through. And she's really responsible, along with Balvanis also, to make sure that we have 7 projects being supported by India, Europe at that particular time. At that hour, there are at least 3 projects are in addition to what was slated. So that was something really good. So this is an occasion where I think we should really acknowledge the efforts that she has put in to make sure that the India-EU collaboration has taken a very good shape, and it's our responsibility to make sure that we bring them to a logical end for the benefit of both the nations. I think a great applause, and let us really thank her for all her views that she has really put in here. Thank you very much, Tanya.
Thank you so much, Professor Prasad. More than a couple of words. Unlike it's the conference of the retiring people. Oh, beautiful. Oh, thank you so much. Yeah.
Greek Indian way.
Okay, you want to hold it? Take care.
Very nice.
Yeah. Yeah. All the time. Patience.
I think it's your turn. They're revealing all the secrets.
But on the day of your retirement.
But exactly. I was going to say, I'm not dumb. Yes.
We still would like to see you, right?
29th of February. So it's the month of the year where there is one extra day to work.
For you, Bob.
Thank you so much. You really took me by surprise. Very much appreciated. India Cooperation on Research and Innovation. We continue, right?
Yeah.
Thank you.
I request. Yeah.
Thank you, sir.
I'd like to request Ms. Tanya to say a few words, please.
You want me to say something? Yeah. Well, you really took me by surprise. It's at the same time a public secret that I have to retire, but I really want to remain committed until the last day of next month and beyond, if I can. But having worked on this cooperation between EU and India has been a real pleasure for me. And I've learned so much. So I think it's you all I have to thank that I was able to work so much and share the commitment and the passion. And I'm really very happy that, as Professor Prasad said, the journey we started together, that I was supposed to end working at the end of last year, but then got these 2 extra months of extension. And those in Brussels who know me know how happy I was about that, because this is really the event that I wanted to see when we started this project, when we said, you will do this research and innovation, we invest, but we want this time compared to other times to see these technologies going to the market. And in the meantime, we have this Trade and Technology Council. So everything comes well together, and I will be very happy to leave a very solid package behind. And let me also take the opportunity to say that my successor, Antonio Marquez, has reached India in the meantime. And so Antonio will follow up on the EU-India cooperation. And thank you that you came, Antonio. And but let's continue as usual and have the work. But thank you so much for all these nice words, this recognition. And as I said, it's been always a real pleasure to do that.
So moving ahead in the program, now we'll start with our session, pitching per project. For this, I would like to invite Professor Rajendra Prasad, Professor Dr. Datta Madamwar, and Dr. Bertrand Wallet to take the session ahead from here.
Morning to everyone. I think this is yeah, it's the time for us to really showcase our technologies, our readiness to really help the society and also get the personal benefit out of it or the institutional benefit out of it. I think we have this good session where we expect all of you to come up with certain technologies which you feel are the best from your point of view, and then which can make a dent in the water technology system, be it freshwater treatment or be it wastewater treatment. And in this particular thing, all of you are given hardly 5 minutes. And then I'm sure if somebody is able to make a dent, that this is an inevitable technology. This is something which is to really point out that you are the person to be contacted immediately after this. That's how the dent has to be made. And I'm sure most of these technologies which we have seen yesterday through with technical details, I think today they will be able to really capture the audience or the so-called entrepreneurs to make sure
that you get the help of taking it to the society and to the market. So now I think maybe.
Yeah.
Yeah.
Then we will have the Lotus project with Bérangère Lebantal and Sudhanshu Mishra. So you have, 5 minutes and you will have a bell ringing.
We good to go? Oh, that's not my clock yet. So can you move the bar of the Zoom? Yeah. Okay, so good morning, everybody. I'm here today to introduce my colleague Sudhanshu to share you about Lotus commercial exploitation. So as a quick reminder of what was said yesterday, and the pointer is not working, so this is not, okay, that's working now. So within Lotus, we've been focusing on creating affordable multi-parameter sensor solution for the Indian market that's composed of a sensor chip assembled into a complete sensor that sends information via a versatile platform to cloud and SCADA. This is valuable enough for the Indian market to motivate the creation of Aeroscope, for which Sudhanshu is a co-founder and which he will introduce. So the floor is yours, Sudhanshu.
Thank you, Beringer, for the introduction. So in India, majorly the water which we consume comes from groundwater, and a lot of impurities have been found in groundwater like arsenic, fluoride, other chemical components, heavy metals. And the Jal Jeevan mission aims to provide potable drinking water to every household, treated potable water, to ensure that everybody has access to safe and clean drinking water. So we see an opportunity here, which we can fill using this Lotus sensor. Currently, a lot of sensors are available in the market, but they are very expensive and cannot be deployed at a mass scale. So we aim to build a multi-parametric sensor, which is affordable and can be remotely monitored. And there's also a lack where we do not have a handheld sensor device, which a technician or even a common person can take it to take water quality readings and then get the readings updated quickly. Second part is Government of India aims to spend around 2% of Jal Jeevan mission budget to install these sensors for water quality monitoring. They aim to create control rooms where a person sitting in a central headquarters can monitor the water quality and the issues in the water distribution network. A pilot project was launched a few years back where it has been already tested in 40 villages across India. And government plans to expand this to a larger scale. Talking about the Lotus sensor, it consists of 4 components. First one is the sensing head, which interact with the ion to identify if there's presence of an impurity. Second is the analog front-end component, which reads the analog signals and converts it into a digital signal. Third component is the Lotus box, which provides energy source through a battery for remote operations. It also stores the data and sends it to cloud for centralized monitoring. And third part is the application of it, where we can use the data to help companies build a specialized solution for water treatment, as well as remote monitoring and control of our water distribution systems. These are the target parameters. Currently, we have completed temperature, pH, chlorine, and TDS. We also have polymers identified for arsenic and fluoride. And we aim to, we are in process of lab testing for these ions as well. Pressure and flow sensors will be integrated along with the Lotus box as an additional component to the sensor. The main advantages which the customer gets by using this sensor is plug-and-play installation. We create it in a factory-made setup which we take and just install using the distribution network pipes. The sensor has a longer life than existing commercial sensor. It also does not require any field calibration. It will be affordable to Indian market, and we'll get the real-time data coming out from the sensors, and we can monitor it using a dashboard. Some of the applications we are currently targeting are water distribution network, which is our first use case we are targeting. Then we want to expand it to other domains where we can use it for swimming pool, water tanker, wastewater, groundwater, as well as irrigation water monitoring. This is our team. Me and Puneet are the founders of the company. I have industrial background of around 10 years, and Puneet has entrepreneurial experience of more than 20 years. So we partnered to start a new company, Hydroscope Technologies Private Limited, with the aim to commercialize this sensor and help in providing better quality drinking water to everyone in India. And we have Dr. Beringer and Dr. Senthil Murugan as our advisors. They are research professors. So I only had the last slide left where I talk about the ask which I have. So we need help in getting European certifications for the device so that we can enter that market. We also need access to, we are looking for a partnership through which we can access the European market, or if we get a direct entry into European market, that would be also helpful for us. And we are also looking for partners to explore applications of the sensor in other industries. Thank you.
Yeah, so floor is open for interactions. Anyone has, yeah, please.
Hello, I am Satyam from IIT Guwahati. If you can estimate the price of one device in INR and Euro, will be helpful.
So there are two ways in which we look at the price. One is the complete setup, which comes with plug-and-play installation along with all the software and everything. That would be somewhere around 2 to 2.5 lakh rupees with fluoride and arsenic included in it. But if we just talk about the sensor in itself, it would cost around 30 to 35,000 rupees, which is at least half the price of existing good quality commercial sensors.
What will be the interval of calibration? Because calibration is very much important to keep the quality of the water. So therefore, this needs support from your organization. So whether you'll be providing this particular support to the remote villages under Jal Jeevan Mission program.
Sir, we are building a lab where we install thousands of devices at once, and then we do calibrations. And we aim to simulate the real life environmental conditions there so that the device simulated in lab can go directly in the real environment. However, if we find certain issues later on where we have not covered a use case, we could also get the data from the site and also combine or try to simulate the same in the lab and calibrate the device and remotely install it through a software.
Jal Jeevan Mission. 5% support funds are provided, and in each Gram Panchayat, FTK field testing kits have been made available. 5 women in each village have been trained to conduct that on-the-spot tests, create data, and put on the Jal Jeevan Mission portal. Now, in this situation, where at each district headquarter, water testing lab has been established. 30 lakh rupees for each lab has been provided. And as on today, there are 1,147 testing labs in the country. I'm one of the advisor and associated with JGM last 2-3 years. I was in that ministry. So how your system gets fit into this mechanism, which is already working on the field and ground, that would require a thought and a redirection to it. Another important aspect is the Ministry of Housing and Urban Development, where urban water supply is through the municipality or water utility or PHED. They would be a better customer for you than the JJM, because the entire philosophy of JJM is different than what you are been monitoring, what you try to propagate. So enter into the market through the urban water supplies, where these things are more important and very much required.
So thank you for your input. So to add on to that, I would like to say that we don't want to say that we are not targeting the urban markets. We are targeting every water distribution company wherever we find an opportunity to collaborate and partner with them. And for rural missions, a lot of initiatives, as you mentioned, are taken by Government of India. But we see there are a lot of still gaps which can be covered through manual testing. It is intermittent, and also although women are trained in villages to do the task and upload the data, sometimes it might not work as we expect because of manual errors or lack of the kit availability. But if we have these devices installed, or we sell this device as a handheld device to do the testing, a lot of chemical or the physical environmental knowledge which needs to be there can be removed. Somebody just goes, dips the device into the water for 5 minutes in a beaker or a container. The data is transmitted to the mobile application, and from there it is transferred to a cloud. So this makes it seamless.
Any other? Online, anybody? Anyone?
Can I come in? Yeah.
Yeah, please.
Kumar. Yeah, thank you. I think as the other expert was mentioning, though I think all the market you should really target, but the urban water systems market, especially under Amrut 2.0, will be the good one. And especially now, about 500 cities across India are trying to plan to become 24/7. In fact, I happen to be a member of the task force itself. The point is, I think there the type of, the market will be much better. Now, having said that, what is the life of these sensors? Any take on that, or is it still in the lab stage to say when we put these sensors, what's the life? And having put the sensors, if there are surprises in the distribution system, what is the takeaway there? What is the next action there?
So, sir, to estimate the life, we have deployed a sensor in Paris Insensity, which simulates a real-time water distribution network. Our sensor has been working since last 8 months there, and we have not seen any deterioration in physical or sensing capability of the device. Our goal is to make sure that the device stays in correct shape and performance for at least 2 years.
So one final small. I just have one observation with you. When you have given the applications, you have given the application as both freshwater and wastewater. Yeah. I hope you are taking care of the ranges, because they'll be distinctly different. So I hope you are taking care of that. Right?
Yes, sir. So those are future applications which we are planning to start. Currently, we are completely focused on drinking water.
Right.
Yeah.
And sorry, you didn't answer me in the sense, if there are surprises, if the water is not acceptable of quality, what is the next action? Is there a way the wall controls will happen? Some message will go? These are all the almost near real-time actions. Is there anything like that?
So, sir, what kind of surprises are we talking about here?
Oh, fair enough. I think
Please
that's
define
exactly
and
the
use
point.
case for me.
This exactly. See, the normal day is the easy to solve for any of us. Sorry to say this. If there is a cross contamination which happens, okay. So one of the simplest things will be the chlorine residual is going to show you that there is a cross contamination. Having done that, what is the action you take? For example, simplest will be walls have to control, this have to control, you have to isolate it. There should be a warning people not to drink that water. These are all the things which is done in any developed country. We need to move towards that. I expected probably some pointers in that direction.
So, sir, actually, we do not plan to install physical valves to control that, but
No, sorry, you don't do that. There should be hydraulic model, digital model, linking it up and all should be done. This is only a pointers for you people. That's all. Okay.
So I will take that one.
Yeah, please.
As we mentioned, the plan is to connect the sensor to SCADA to be able to connect to the existing infrastructure in the urban area. Talking about urban area. In Lotus project, we've developed a firewall-based infrastructure to detect leakage and contamination in the network based on sensor data. So if we detect a problem in the network, we can apply the rules of operation that's been defined through fireware, and that's already available. That's been developed. We showed yesterday this infrastructure model through IPANET of Guwahati WDN. So that's for urban area. We also have use case in tankers, so using the sensor in the tanker distribution system, where actually the sensor is used to optimize the operation of the chlorination system. So here, if the sensor detects that your tanker is not chlorinated enough, it pulls more chlorination. Or if your sensor detects that the arsenic level of your tanker is too high, you send it back to the facility to get more, to get fresher water, or you use the water for limited use that are not drinking water. Last item, there's discussion, there's a reverse osmosis solution, I'm going to make it. And same, that can be used in rural areas, small stations for desalination or for chlorination that can use a sensor. So the idea is to react in real time if contamination are detected to trigger chlorination. And typically the chlorination station that was developed in Lotus is solar driven, so it can be installed in rural area. It doesn't have to have a huge power. It can be a very small machine. So that's the highlight. Now, of course, we're in startup mode, so we need to know what's going to be taken up and what's not. So I'm not going. I don't have a crystal ball, but that are the options that are offered to us based on Lotus work and lot of actual technology tested in Lotus.
Thank you. These are all pointers to help you people to improve the product. Thank you very much.
Thank you for the input, sir. And regarding the actions you were saying, so using the softwares, we monitor the water quality from each sensor, and we know the geolocation of the sensor, so we can trigger an alarm in that area, or even later stages, we can send an SMS notifications to people in that area to not drink water for a considerable amount of time until next notifications are released. So we can make some solutions on the software side, but from the hardware valve control and all, we have not thought about that. And thank you for the input. We'll start thinking in that direction.
Sure. Thank you. Please target at 500 cities 24/7.
I'd like to add one point here. You have to incorporate with your program sanitary survey. Under water safety plan, we have to carry out sanitary survey. So state government PhD has now started. Whenever we are not getting residual chlorine in some places, we have to go in there because you have GPS you mentioned, and then we carry out the sanitary survey. For example, a pipeline is crossing below the culvert. There could be a joint. So we identified that and rectification is done so that people get safe water. So this is the action program to be taken, and algorithm for that you have to prepare different type of pipe water supply system or spot sources or whatever may be the case.
Okay. Thank you for your input.
Thank you very much, sir. I think we need to wind up here. Sorry, thank you. Thanks a lot. Thank you. We may now invite Pani Potter.
Well, I think the presenter is online, Dr. Fabio Ugolini.
Correct. Good morning, everybody. Can you hear me?
Yes.
Very good. So I'm going to share my screen. Can you confirm that you're seeing my presentation?
Yeah, we can see it.
All right, then I'm starting. Good morning, everybody. My name is Fabio Golini. I am the Exploitation Manager of Pani Water. Today, I would like to pitch a technology that we developed in the project. It's a submersible UVC LED device, which is a component of a larger water purifier. In India, 97% of the households are using a drinking water purifier, and 10% of those are based on UVC
Fabio, we've lost
disinfection.
the slides. Okay,
Sorry.
Yeah.
Let me try to reshare.
No, we can see.
No, we are sharing from here. Okay. So just ask to move the slide then.
Okay. So are you seeing the slides moving?
Yes, now yes.
Okay, perfect. Sorry about that. So in India, 97% of the households use a drinking water purifier. About 10% of those are based on UVC disinfection, and that's around 28 million units in 2023. Now, UVC disinfection is largely obtained through the use of mercury lamps at the moment. Mercury lamps, they have some disadvantages. They are short-lived, they are inefficient, they require a warm-up and cool-down time, during which they are essentially just dispersing energy and not disinfecting. And they are a health and environmental hazard since they contain mercury. The Minamata Convention, which was signed by India together with a lot of other nations in 2017, is driving the phasing out of mercury from everyday products. So we are proposing to replace mercury lamps in UVC water purifiers using submersible UVC LEDs. And those LEDs, they are winning across the board if you compare them to mercury lamps in terms of efficiency, lifetime, size, costs. Really, the comparison is one directional in this sense. The sensor that the LED array that we produce is patent pending in India. It's backed by published results in Pani Water, and at the moment we can consider it TRL6 because it has been demonstrated in actual water purifiers that have been used in households and in the campus of one of the partners in the project. The market that we're looking at is the market that now, the water purifier market, especially the one of UVC water purifiers. If we look at the total available market globally, that's about a $26 million market. If we look at the serviceable market, which are the UVC water purifiers in India, we are talking about a $300 million market. Our obtainable market, given the current manufacturing capacity that we have in the Pani Water Consortium, it's very small. It's a fraction of it. It's about maximum $6,000 market. So we really need to work on the manufacturing now. Competitors in this market are companies that are already producing UVC-led water purifiers. We have 3 of them here. Those companies, they produce outside of India, and their product is quite high-end. It tends to be a little bit pricey. What we are looking at really to enter the market, it's through the companies that are currently selling mercury lamp-based purifiers in India. The 2 largest ones are Eureka Forbes and Kent. They together have more than half of the available market for UVC water purifier, and they are proposing a lot of solutions that use at the moment mercury lamps. So what we want to do is to create a joint venture between BITS Pilani and Quality Photonics, which are 2 partners in Pani Water. This joint venture would have in-house manufacturing capability for submersible LEDs production through Quality Photonics, which is a company that produces LED solution. And the business model would be B2B business towards producers of mercury lamps-based purifiers. So our projections, well, now we are in 2024. We need at least 5 years. That's what we think in order to start turning a profit on it. At the moment, this year and next year, we will need to invest very heavily in, in our manufacturing capacity, in certifying the product, in validating the market, and in staffing the company. And as we are able to scale up the production, we expect that we can start turning a profit in 2029. So our ask would be 80,000 lakhs to cover the first 4 years of company lifetime. These lakhs would be invested in improving the manufacturing capability so that we can bring our manufacturing from 2,000 units to at least 100,000. Initiating the staffing of the company, certifying the product, validating the market. Now we are targeting 2 main companies as customers, but that's a risk. We want to have other possibilities. And then investing in our sales team. We expect then an investment as a loan, which is done now, would be repaid in 200% in 7 years, but we are also willing to consider investment for equity. And the team, the 2 leading figures in the team would be Mr. Vijay Gupta, who was the CEO of Quality Photonics and will be the CEO of the joint venture. Mr. Gupta has an extensive experience in both manufacturing and commercializations of LED-based product.
Dr. you need to conclude now.
Yes, and Dr. Alan Prakash would be the Chief Research Officers, and Jamie Gandhi, Lakshman Raikar in operation, and I would be Advisor and Internationalization Manager. Thank you very much.
So do we have question in the room on the lead disinfection? Not in the room. Do we have question online? Okay, Crystal. Okay. I don't know. In the chat, I don't know if it's difficult to read.
Does immersion affect performance of the LED? I can't read them. What challenges whether if someone can read them out from the laptop screen?
Yeah, Samrat, can you please read the online question if it is related to this particular presentation?
Yeah, we have a question from Dr. Swati asking, does immersion affect performance of LED?
Well, it doesn't affect the disinfection performance in a negative way, if that's what the question means. But immersion is necessary. We've seen that it's necessary because in wall-mounted devices, the LED component tends to heat up very quickly, and so by immersing it, we facilitate the heat dispersion. And actually, the innovative component of this solution, which is subjected to patent, is this immersibility of the LED sensor so that disperses heat in a better way.
Fabio, I would like to take it further. The immersing LED is very much required because in the current scenario, the efficiency of LED is just 1%. What do I mean by 1%? You put some amount of current, 99% is generated as heat and 1% is the radiant power. So a lot of thermal management is needed. And this is the aspect this is the problem we addressed and patented it. So that's the immersion is very much needed going forward. Thank you. Yeah. Can you read the next question? So maybe the word for that. Yeah.
There is another question about normal depreciation similar to that in air. I don't know if that's a question or.
So do the LEDs depreciate at the same rates in water as they do in air?
No. The LEDs have a large lifetime compared to mercury. That's for sure. We have backed up results, published results. With my industry partner in KPP, Hyderabad, we have evaluated and monitored the stability for almost a year. So a single device, which is just a small one, four LEDs, for 1 year we tested and it is very, very stable.
Another question is from Sir Christian Ferrero. How much is the irradiance of this UV system?
Okay, great question. So in the mercury technology, it's about 200 watt, watt. And the current LED technology, the maximum is in milliwatt. So today in the 5th generation LEDs, it is about 200 milliwatt. What we could play around is the 1st generation LED, which is 20 milliwatt. And I hope that we would be able to procure this and improve the design, enhance the output for the performance indicators that we have been showing from yesterday. So with this new generation, with about 20 or to 200 milliwatt irradiance, centimeter square, it's going to be great. And you have good output for the water that we receive. At least for 1 year backed up results, what we have in Goa, this is really impressive.
No more questions online at the moment.
Okay, thank you very much. So congratulations. There is one question in the room, sorry.
Whether is there, for the disinfection, whether is there any limit with respect to the input fecal coliform? This is important in the sense that sometimes it may be more with respect to some type of water. Another question, whether turbidity is interfering with respect to your performance.
Sure, sir. Thank you for this question, sir. So we have been, these are the results. We have been monitoring the water, drinking water, which we receive for almost 1 year, 2022. So Jemi Gandhi is here. So her role is to go to the 5 different sampling points, see the turbidity. So we had no issues with turbidity. It is always less than 5 NTU, number 1. Next is, it's very dynamic. We did a statistical analysis of this bacterial enumeration. So it ranged from 0 to 10 power 3 CFU per 100 ml. So this is what WHO says. And now, unlike the laboratory results, what we really able to show is the 3 basic indicators. That is the total heterotrophic colony, then total coliform and fecal coliform. So in the fecal coliform, we see about 60 to 100 about sometimes, and it is more prevalent during the winter and summer. Monsoon, somehow it gets diluted and we don't see this. So we are now with this optimized results, which we published recently. So an input quality with 10 power 3 to this works. So there is also WHO recommended chart. Professor Linden has contributed significantly. It tells about how much UV dosage for a corresponding bacterial species. So this you can play with the irradiance, the previous question that we had. The irradiance into time is equal to your dose. So that the time can be adjusted if you have a valve and make the HRT, I mean the flow rate. So this is how we can control and say if we have also our experience tells that if it is more than 10 power 3 in the laboratory, it's like really a dirty water. You cannot drink it. So we have to little bit reduce the valve and in that unit, and you can increase the dosage. So this is the optimization we did. Thank you.
Thank you very much. So thank you very much for the pitch and the questions. And we will move now to Pavitra project, Dr. Miko Hanel and Dr. Nadine Khalil.
Just using the time, Professor Nadim Kahil left, but we replaced him with our dissemination partner for the technology I'm going to propose. Mr. Patil is from Ökosan Service Foundation, and he will be our partner in India for rolling out the technology. But yes, Pavitra was introduced, and we have 14 technologies. We selected one which I was in charge of. Oops. And the technology is a really simple one. And we have a high TRL, and therefore I'm going to introduce it shortly. If the presentation is back. I mean, the problem, I don't have to spend time on it. We have a lack of treatment facilities, especially in rural areas, and we are focusing on water and nutrient reuse. The concept, we have established a 1 hectare system in Aligarh. It's a short rotation system based on bamboo, willow, poplars. It's a nature-based system. It is quite easy, and it's based on fast-growing trees. I'm not talking much about how much our system costs. It's more that the percentage of water and nutrients we are able to reuse. Here, just some pictures quickly. This is the poplars in something like 1.5 years. For poplars, we are reaching around 80 to 90 tons per hectare. The willow, you can see here, also exploded actually last 6 months. And the biggest results we get with bamboo, we are reaching 200 tons per hectare per year. I mean, for Europe, this is impossible, but in India, you have really, really suitable conditions. We calculated all the costs. This is an example for a 1 hectare system serving around 2,500 to 3,000 people. The last figure is important. For an average cost for 25 years, we need around 3,000, let's say 4,000 US dollar. Taking the people into account, it's like $1 something per person. The business model. And now forget about the cost for the system. Just for the biomass we produce, I was taking the actually market price, learning that, for example, bamboo can be used to buy ethanol and the income could be much higher. These are really conservative data. You can actually harvest. We went down from 200 tons to 100 tons, just to be on the safe side. And then we have like, we calculated this $96 per ton. The income minus the cost, you make around 5,000 US dollar per hectare as a farmer. Of course, there's a negative point. You have to wait 3 years before you can harvest. But even then, making an average 5,000 US dollar per hectare per year, it's much more than most of the farmers do in India. That means the treatment is just a side effect. You can keep it as a business. And therefore, we would like to push this to a more large-scale level. We just made it together with a data satellites for the region of Aligarh, 400 square kilometers. We calculated all the villages, one city, and then we checked out what are the costs for the whole system, what are the biomass production, which is possible in this region, just focusing on bamboo, and the value. And here you can see the data. And if you look at India, we have about 4,000 cities with less than 100,000 citizens. We have more than 650,000 villages. This is not a system treating high toxic wastewater. I'm just talking about standard rural villages, which could have a solution free of cost, producing biomass, which could be marketed there or even internationally. The business model, this is not easy, because the business model, it sounds easy, but you need experts involved. And therefore, what I would like to see is a franchising model. That means you offer a package of sensors, of pumps, of pipes, and knowledge to stakeholders which take it. The stakeholders could be farmers, municipalities, local experts in all India, which needs to be trained and then can use it for a long time. The requirements which we would need is a positive listing of the technology that the Indian government on local level says, yes, it works, and we approve it. And of course, the freedom of the local communities to decide to use it, because this is sometimes a tricky point. And of course, for the first 50 or 100 systems, you need a reliable monitoring scheme in order to make sure that, that you don't screw it up in the first case, because then the idea is burned. So far, we have the results from Aligarh, which is running for 2 years. We're fulfilling all Indian requirements for treatment. We have a beautiful biomass production. And now we have to think about commercial use of the biomass produced. But here you have a wastewater treatment, because we're all talking about we have to reduce the costs by 10%, by 5%. Forget about it. If you get the water and the nutrients for free, you don't have to charge the municipalities. You can turn this one into a money-making process. And that's really shortly, maybe one sentence for ruling out into India from our partners.
So yes, as a dissemination partner, we see a lot of potential in this simple technology or a mechanism to manage wastewater for villages and very small towns. There are other benefits apart from the treatment and safe disposal, which I see is two things. Most of the treatment technologies we talk about do have capex and opex, and they are recurring, and to sort of maintain them, we need some sort of funds. This one doesn't need it, because as Mirko said, the biomass keeps on coming and the mechanism works. The other thing is shift to bamboo. India recently announced blending of ethanol into petrol. And currently in India, there are just two raw materials, sugarcane and rice, which is used for ethanol production. And there are already researches which have been published that India needs to shift to an alternative raw material, and bamboo is one of the biggest raw material. Recently in Assam, biggest biorefinery, bamboo-based biorefinery is also being set up, which will be operational in March. So we see a lot of potential in this system, where the wastewater industry also gets benefit, whereas the other industries, allied industries, also get a lot of benefit. That's it. Thank you.
By having still time, because this is the beginning. We are using bamboo because bamboo was handy. In Europe, we're using poplar on willows. But because we are limited with the winter time and with our availability of plants, in India, you have so many plants which have a high economic value. That means we can actually sit together with experts and discussing. Of course, you have to treat the water. This is the main thing of the system. But there are many, many other plants which have probably higher economic value, which can be used. That means this one I would like to commercialize, but at the same time, you can do research and development to check out what else can be done with the system. Thank you very much.
Thank you. Thank you very much. Thank you for the time. You were 5 minutes sharp. I didn't have to ring the bells. Yes, please. Question from the audience.
My question is, in how many places in India have you tested this technology?
For short rotation copies, you have several thousand places around the world. In India, it was the first time we invested in like a 1 hectare system in Aligarh. It was the first time.
Only in Aligarh?
Only Aligarh.
Yes, that's what actually my question was about. to get it, you need to test it many places in many
Absolutely.
geographies because of the climate and the geographies.
You have to check the soil, the climate, and so on. Yes.
Aligarh is more maybe subtropical dry or maybe semi-arid region. So you need to go beyond that and see and check, and what actually your counterpart said about the bamboo mission, as well as bamboo as raw material for ethanol production. So why the company is established in Assam? Because the availability of raw material. So do you think that other parts of India, if your technology is there, so can they go for such kind, because looking at the size of the cities and all those things, so how this technology is replicable to many parts of India? Any take on that?
Our proposition is this should be applied in smaller towns and villages, mainly. Of course, bamboo is one of the things we have tried and tested. But as Mirko said, there are other plants as well which have higher economic value. For example, tea tree. Tea tree oil has a higher economic value and is non-edible. So wastewater fed yield can be easily used for generating that oil. So there are multiple such.
So are you targeting which kind of land, degraded land, or because cultivable land cannot be used for purpose, the population as well as the food requirement, food security of the country. So which type of lands will fit for this kind of?
So no, I mean the land has to be checked before, but in Europe actually is used on degraded land because this is like it's the only land available. But you have to check the water holding capacity, like some physical measures. But as long as the plants can grow on the land, you can use it. In China, we have used this one to actually make phytoremediation on heavy metal polluted soil. That means as long as the plants are growing, you can produce biomass with it. And of course, you have to check the treatment performance. But this one would take a long time to go into the details, how the soil actually has to characterize. But this is the point. You need a lot of knowledge to set up the location, to set up the site. But then when it's running, it can be done by farmers. It can be done by low-skilled people.
Okay, thank you.
Okay, thank you. We had a question. No, okay. Switch.
I have 3 observations. I think India has a very long history, almost a century-old history of reusing sewage and the problems. So you might encounter something called sewage sickness. Please address it after 5 years, what you need to do. Then second is, you may not find, as we are going something called ODF in our country, in rural areas, you will not find black water, that is sewage. You will find gray water. So you need to adapt it to that kind of a situation where nutrients are less, but water is more. And third, already they have banana, sericulture, forage grass, and more recently, you have sweet sorghum being cultivated on this. So that might make your profitability a lot more useful. And sweet sorghum to biogas is something that's being tried across the country rather than bamboo.
Yes, you're completely right. The number of plants are unlimited, I think. But of course, you have to make sure that the plants are able to have the root system for the treatment. Because this is one point that some plants, sugarcane, for example, doesn't work. It sounds nice, but it doesn't work in the end. That means you have to be careful by selecting the plants fulfilling the job. We actually took gray water mixed with black water. That means the BOD in Aligarh is around 100. For European, this is unbelievably low. In India, you find many places where you have mixed waters, but having like a standard village where you have a drainage system, then the collection pond works perfectly well. This is designed for this one. But of course, the design can be really flexible.
Thank you. I see one hand raised online. Two hand raised. So Professor Mohanty? No. Mohan, Professor Mohan, sorry.
Yeah, thank you. Thank you for the very nice presentation. And the only thing is with the Jal Jeevan mission coming in, and obviously the water supply will improve and any standard practice, 80% of it comes out as sewage. So automatically we're going to have a lot of sewage flowing out. And that way, I think the natural systems really play a role. Having said that, one of the advantages which you already mentioned, I just wanted to draw your attention, the type of plant what you're growing becomes a carbon sink. In fact, that itself environmentally you get back something, indirectly you'll get back. More important, all this bamboo and other things could be a part of the construction industry. In fact, they're really needed. So the type of things what you grow, it's going to be extremely useful. Just an observation what I wanted to say. And definitely these are all the things for generally you get all the sewage goes into only degraded land in many of the villages. This is where if you want to grow, it will be the right place to grow this bamboo and other place. Thank you.
Thank you very much.
Thank you, Professor. And Mr. Jensen? No? Okay, you are muted if you are trying.
Can you hear me now?
Yes.
Yeah, okay. I don't know, I didn't think I raised my hand anyway, but it's very interesting to follow all these pictures. And I do have one question here. Now, using 1 hectare of land, that's a lot of land. And I just wanted to know how is your view on the competition you're doing with actually food production? Because in India, food production is also a big topic, yeah? So have you done some research or some talks with farmers? I know the financial incentive that you're positioning here, that is interesting for the farmer. But how does the government or municipalities or everybody look at the fact that using 1 hectare land for sewage treatment instead of food production? What is the case there?
Yes, this is a really important question, and thanks for raising it. This one was the main concern. We talked to the farmers, and by telling them we need 1 hectare for treating wastewater, people say, okay, that's it, there's the door. But we are not using the land for wastewater treatment. We are using the land for producing a big amount of biomass. And of course, food and biomass, we can discuss it. But I think we're talking about a bio-based circular economy. And India has the potential to produce big amounts of biomass. You have to make it really efficient and high productive. And I think this system can be one possible solution, because you produce on the footprint, you produce a lot of biomass, which can be used for many, many purposes. And therefore, it is not land for wastewater treatment. It is normal land for high effective biomass production, plus doing the treatment job. And I think talking to the farmers with the figures, they would be more than happy to take over the system, because they would double or triple their income. And I think this is the decisive point. Of course, the food production is one key point, but as we actually can take land which degraded or land which is not used so much, we have a starting point, and then the market will decide which solution is possible. Also keep in mind that a village with like 1,000 or 3,000 people needs 1 hectare, and that's it. That means there is not the risk of needing all the fertile land in the village. I need 1 hectare for 3,000 people, that's it.
Understood, thank you very much.
Thank you very much. So we have a slight delay, so we will break now, and we will come back at 11:30 with the last project for this session. All right. Thank you very much.
Rangekar are already there. Maybe we wait still 30 seconds, because I see people coming in big numbers now.
Just said if you pitch 2 technologies, then you can take over. I will tell about out of 10, 8 are almost done for commercialization. I don't have. Two technologies we are pitching.
Yes. Okay, so the floor goes to Saraswati 2.0.
So very good morning to all of you. In Saraswati project, we have piloted total 10 technologies. Out of that, almost 8 technologies are ready for commercialization. 2 require further investigation to make them ready for commercialization. And here we are going to present 2 technologies. So the pilot 6 comprising of USB reactor followed by electrically conductive biofilter. So this technology, we monitored the performance for over 15 months, nearly 1.5 years now. The scheme consisted of USB reactor, followed by electrically conductive biofilter, followed by anoxic. That modification we did, European Union partner suggested only electrically conductive biofilter, which is mostly aerobic. We augmented it with anoxic portion to support additional denitrification. Then it has pressure sand filter, followed by electrochlorinator, followed by UV, and then finally activated carbon filter to produce reusable quality treated water, which is fit for any purpose. The existing wastewater treatment systems, they are challenged with low nutrient removal, high footprint, poor effluent quality, sensitive for the fluctuations in the input organic matter concentration as well as flow. Then most of the processes are energy intensive or they require high chemical dose and high sludge production. So the technology, what we demonstrated, offer a solution for all this. So it has a low footprint because it is constructed vertical with the electrically conductive biofilter treating USB effluent. Then that is why the footprint is less. The high nutrient removal efficiency is demonstrated by this plant for both nitrogen and phosphorus removal. Almost 80% nitrogen removal has been accomplished. High effluent quality, producing treated effluent with less than 3 milligram per liter of BOD, less than 30 milligram per liter of COD. Even total nitrogen is less than 10 milligram per liter, values are around 6-7 milligram per liter. And MPN also, mostly close to zero. Sometimes we do get 1 or 2. Then despite varying effluent characteristics, it has showed a stable performance. No requirement for aerator and skilled manpower. So operation cost is less, only cost of pumping is involved. Only table salt is required for the electrochlorinator, so commercial salt can be used. And in a 1.5 year of operation, we never required to handle the sludge. So sludge handling and disposal also is reduced. So that makes it a very sustainable technology, particularly for remote application or small flow treatment applications. So the business model, we look forward here, the producing treated water, which is suitable for irrigation, for toilet flushing, for public place cleaning, gardening, as well as for industrial water supply. It will also create the job locally while solving the environmental protection problem and also treating wastewater in the economical way. So the market opportunity, whatever the market survey that we did on Google, so we expect the market to rise year by year. And the key players that we have are the competitors are big players, Larsen & Toubro, Ion Exchange, Thermax, Veolia, Suez, and many other companies are there in place. But however, we are trying to provide the affordable solution for the existing costly or energy intensive processes that are being currently used in India. So market values of the treated wastewater is expected to rise to 1.9 billion by the year 2050. And this is how the market rise that we expect in the wastewater treatment infrastructure or wastewater treatment business. And that is where we expect that the technology that we demonstrated has a lot more scope, particularly in the Indian context. Over to you, Dr. Marcus, for taking it further for another technology.
Thanks for the contractor. So the second technology we're going to pitch will be the Cambi thermal hydrolysis process. So this basically is used to treat sludge with several benefits regarding subsequent anaerobic digestion. And of course, it's a big topic in India because India has many wastewater treatment plants that produce huge amounts of sludge, which needs to be managed in a sustainable manner. And the Cambi process can produce pathogen-free biosolids. It can be used as a first fertilizer. It uses the digester volume and increases biogas recovery. You can see in the figure below what some quantification of those benefits. And of course, Cambi plant could be installed at any treatment plant in India. So the market is of course very huge. Adopters would be municipal utilities and industry. The business model in India, it's mainly contract-based, tender systems common, but also the HAM, hybrid annuity model is applied widely, and also PPPs are upcoming. So in principle, Cambi would ship their technology from Norway to India, their core technology, but ancillaries could be outsourced to India and produced locally, depending on the pipeline of projects that would come up for Cambi. So already is this solution? You can see on this map, the CAMBI has been applied meanwhile almost all continents successfully, like Europe, US, etc., but not yet in India. And the reason for this is that in India, CAMBI was considered at the start of our project of a tier L only 6, because in India, as I mentioned yesterday, the SBR systems, they are widely used, CTEC system, and they produce a sludge with extended aeration time, which is unique to the CAMBI system. So that was not yet tested. That was the purpose of our project here, to test it in pilot 7 with IIT Roorkee, and the results have been excellent. So in principle, this technology would be ready for adoption. The next step would be to reach tier L9. This would need an investment of around 15 million euro or 135 crore Indian rupees to build the system for a small township. And the main issue is here that who is going to take the project risks. So can we talk to international donors like World Bank, etc., but they are saying they do not want to take this risk because in India, there's a total missing of master plans for city. We know India has fragmented planning with no master plans. And that's, of course, the main barrier for such projects. And the other barriers, like in India, is lacking updated regulations, policies, etc., for sewage sludge management. And for cost competitiveness, we would need to make cost comparison, including taking into account the full cost of existing practices, like the true landfill cost, etc. And of course, how can we change those barriers to drivers? So first, India would need to develop its own policy for sustainable sludge and biosolids management. Ideally, it also would take into account cross-sectoral policies, and key driver could be the co-digestion of sludge with food waste. And in this case, European Union has many decades of experience to reach this state. Of course, India has not time to wait for so many decades, but has to leapfrog it. And to achieve that in a much shorter time frame, and hence India can learn a lot from Europe in that regard. So tariffs, circular economy, sludge directive, etc. And also EU should be maybe more proactively approaching India in that regard, because all the other countries like US, Japan, they're trying to influence India in that regard as well. So for the benefit of our SMEs, we should try to foster or to make European policies here more widely known. And if it works in India, it also would work in other developing countries like Africa. Thanks.
Thanks, Marcus. Thanks, Professor Gangotra. I would start with the online question. There seems to be something in the chat. If may I see a message there?
For the second one, actually, second technology, I want to ask a question. Have you identified the partners from India yet for manufacturing?
CAMBI started its operation in India.
CAMBI, I know actually they have already their own technology also.
As mentioned,
but this technology, how it is different from the already available technology with CAMBI? Because I have met some, a few people from CAMBI, and they're also talking about the same thing, similar kind of technologies. So is it different from the already existing technology from CAMBI, or it is totally independent of what CAMBI already means technologies from CAMBI already available in the market?
It's the same technology, but as mentioned, the CAMBI technology has been designed for sludge with short aeration time. But in India, due to the SBR processes which are prevailing here, Indian sludge is based on a longer retention time.
Okay.
And for
to SS ratio is less here.
Okay.
And the 0.5 to 0.6, whereas in conventional activated sludge process it is 0.7 to 0.8. So obviously the performance there is a difference.
And this was tested at IIT Roorkee. The tests have finished just now, and the results were very positive. So we conclude that now CAMBI in India has a tier L of 7 to 8, but to reach tier L9, it would need to be applied in a small city, so the whole city, small town or so. But that would require an investment of around 15 million euros. And yeah, so far, because of the barriers I mentioned, lack of master plans, no policies in India, there's no one willing so far to take this project risk.
Any bottlenecks about the policy in terms of policy perspective, do let us know actually where it is there. So that we can work on that also with Mahua.
The proper master plan for quality of the sludge. We talk about classes like that. So if we fix that and implement that strictly, then such technology will have. So if proper policy has been laid down, for quality of the sludge that is applied in the agriculture land, then in that case it will help.
No, the biosolids that are generated, that we are working on that policy aspect of that. So maybe in the next 6 months, it will be operational. So it will help you also. But that apart from that part, because you are talking more about the investment as well as findings with your partner to take this technology forward. So that part, maybe we can see. So please be in touch with us.
Yeah.
Okay, thank you.
Thank you. I think Cambi already is very active in India, and they're also promoting their technology to Mumbai, to Kolkata. But of course, they are still waiting to get an actual contract so they can start this larger scale pilot project.
The first one that you have shown, I find that it will have a very good market in the sense that the USB and then your electrically conductive bioreactor, which is fully aerobic, as we mentioned, and then anoxic zone. This will be removing the organic part as per requirement, as well as nitrogen, phosphorus. Issue is that with respect to electrochlorinator and UV, both you are using. It can be only electrochlorinator or UV. That is to be according to the demand, reuse of water. Another is activated carbon filter. So therefore, certain unit can be compromised. I mean, that way with respect to the buyers. So this is my suggestion that you can discuss. Okay, this is my suggestion. The second, with respect to Cambi, issue is that we have most of the cities and towns are having on-site sanitation. Our mega city, metro cities are having sewer system. So therefore, the house connections are there, number one. So therefore, the sludge which will be coming from most of the cities and town, already it is getting digested in the septic tank. So therefore, the Cambi technology with respect to thermal hydrolysis to get more methane biogas from the digester, this is need to be looked into. Another very important issue is that in our sewage treatment plant, we are now avoiding primary clarifier. We are going for extended aeration system, secondary clarifier. When it is extended aeration system, the sludge is getting also digested in the system. Therefore, the quantum of biogas, therefore, could be limited. So with this aspect, the market could be a little limited with respect to Cambi. This is my suggestion. I mean,
but what to mention is the acceleration time. This is what was tested at IIT Roorkee. So they tested that.
IIT Roorkee, they tested it SBR at extended aeration time.
I do understand.
And nearly 3 times increment in the methane production has been observed as compared to the raw.
They use SBR sludge also.
Yes, yes.
That's true. But this is my apprehension. Yes, still.
You're right. I will quickly respond to first comment. As you said, we have UV as well as electrochlorinator. So those could be operated using solar power. So that way sustainability can be imparted. Okay. And the purpose why we use is concern of xenobiotic compounds, the emerging contaminants. They are there. So first we chlorinate and then send it to UV because of the chlorine radicals. Some oxidation of some of the biorefractory compound is possible. But still we are getting effluent TOC about 20 milligram per liter. And that is difficult and that require further treatment to call it really potable water, which is free from any presence of antibiotics. So that's the research aspect of it. But as you said, these units can be eliminated if the end disposal is agriculture or horticulture, and cost can be minimized.
Yeah, thanks a lot. Just one thing, I saw online popping up a message. Somebody was asking, the company is Cambi. I mean, they are asking the name of the company, maybe it was not clear. Okay, so. Yeah, what's the name of the company? Yeah, it's Cambi. Yeah, CAMBI.
Could you think of trying to address the problems of all the apartments where you have underground wastewater treatment plant? Your technology fits exactly there because they don't operate these systems because all the aerators make a lot of noise, the compressors, so they avoid operating. Yours would be a good replacement because it's noiseless on one side and you're vertically stacking. So the space required, especially in a place where per square foot costs 20,000 or 30,000 rupees, your selling point would be that it is compact, it is stackable. And I think that's the market you should address, because each city has at least more than 5,000 such locations where you can apply this, your technology with UASB combined with the bioelectric filter.
Thank you, Professor Chanakya. We'll look for.
Gangrekar, one quick thing. The first technology, what is the cost analysis? You didn't make it because I thought it must quite cheap.
It is a little costly in terms of capital investment. We are in the process of evaluating life cycle costing. In another month, I will be able to give you exact numbers. But as of now,
the recovery
as of now, the capital investment is more, but operating cost is negligible. So it will come life cycle costing around 10-11 rupees. But I need to fine tune those numbers.
Yeah,
so
if it can be slightly still smaller, I think you would really have a big market. Then the second component is the one which is tested in Roorkee. What was the capacity?
Kambi.
It was a very small one, right?
Yeah.
Kambi. But the
8
capacity
kg
is
dry
very
solids
small.
per day.
8
kg dry solids treatment per day. I mean, the sludge
It was
with
5 kg, something like that.
That's why it's only till end of 7 right now.
Any other question in the room? No, online, there's a new message maybe, or no?
No questions at the moment.
Okay, fine.
Online.
Fine. So we move to the next team. I'll say thanks, Marcus.
Thank you.
Thanks.
Thank you.
Professor Makara. So in the India H2O team, Philip and Anurag. So Philip, you are online, right?
Hi, yeah, I'm here.
Should be set, no? Or fine? So,
yeah.
Anurag,
Good afternoon,
floor is
everyone.
yours.
And good morning, Philip, if you are there.
Good morning. Good morning.
Myself and Philip, we are here to represent case studies and what we have come out in our projects. So this is, can we make it in slideshow mode, please? Can we make it in slideshow mode, please? Excuse me. Yeah, thank you. Well, sorry. So groundwater salinity, we all are debating since yesterday that this is a big problem. So these are some data and some economic calculations, how the market lies and what is the potential of this market. And the two main challenges, what we observed is that this is energy intensive process because it needs pressure to pass through its membrane. And other one is that recovery is a big concern, and reject management. So recovery and reject management, this comes parallel. The more reject we draw, so more is the problem. So if we could increase recovery, the volume of the reject will minimize, and we can find ways how to deal with it. So this is the basic theme. This has been the basic theme as far as brackish saline water treatment is concerned. So we came up with this unique solution. My counterpart, Philip, we together created a batch ROFO system, which can be scaled up and scaled down as per the requirement. We can create customized designs. Another advantage of this technology is that we can implant the system where it is required. So transportation cost reduces, no piping, no need to transport to remote places. We can customize the design as per the requirement for say 100 households, for 1,000 households, or for a village community or so. And whatever reject in less volume comes out, we have come up with our Israeli partners, Moshe Sagi at Ben Gurion University. We can grow some helophytic crop, Salicornia, what you see. And this is all integrated with solar panel. So grid is there. So what we are doing, we are whatever we are generating from solar, we provide to grid, and we take it from grid. But grid independent systems can also be created. It will require only battery support and some bigger panels because this will work on peak load analysis. So this system is working well. This is a very remote place, very near to coastline, near Somnath, and villagers are running this. So this is so user friendly that we gave training to villagers for 4 or 5 days, and they are running it, and they are even selling the water to make the system sustainable. So I'll skip this. This is very complex. So the simple solutions, we witnessed that they come after complex and a lot of brainstorming. This is the system which we described yesterday also. I will not take much time. So this is not continuous RO, this is batch RO. So this work on pressurized mode and purge and refill mode. In forward stroke, we pressurize the water. It passes through the membrane, and in the reverse stroke, the piston moves back to its initial position. So it cuts down the energy requirement, what you see here. For continuous RO, we need to make a consistent pressure all the time. But here, pressure exchanger works as an energy storage device. We came out with another unique thing. These are low-cost sensors, and this work on an app system. So we can monitor the parameters which are getting into the system, coming out of the system, all pressure, flow rates, TDS, salinity, etc. We can monitor from the remote place, and we can communicate to the villagers what corrective measures need to be taken. Like when pressure increases, this is an indicator that fouling has occurred. So we have kept all the necessary things there, and we have trained them how to do the membrane washing also. This is the system for dairy and textile wastewater treatment. We are still in design phase, and very soon we are going to implement it. These are few things in bits and pieces. We need to integrate them all. So this is a stake which you see at the left side, and next to it is a unit, electrodialysis unit. And only the stake part we need to change as per the category of the raw water is. So this is like heart of the system. So all peripheral arrangements will remain consistent, will remain there. And we need to change this stake only for brackish groundwater, for dairy wastewater. We will be using BMED. This is again a business model, and we created the system because this is driving on solar PV. So we did calculations on 8-hour basis. This system is capable to produce 800 liters per minute out of 1,000 liter feed. So on that basis, this is done. If we run it for 24 hours, this small system even. So ROI is very efficient and 36%. If we scale it to 5 times, then this is 151%. This is another picture to reflect what are avenues which we can generate. So this is water, which is the principle, which is the basic thing of our design. And with the reject also, what we grow salicornia. I carried some sample if someone wants to see it, how it looks like. And if salicornia also uptake the market, then you can see how big is the opportunity for stakeholders. This is our team. I'll go quickly. We have registered this company in the name of the trust which has given us the land and facilities to install our system. And these are indigenous designs of how to carry this potable water and to market it. Villagers themselves, they did it. So this is the unique thing with it. These are few selling points. As I told you, different modules can be created because this is our own work. So we can upscale, downscale. This is the size of the pressure exchanger only. And this is a matter of volume and to synchronize the pressure accordingly. At what stage of forward stroke, what pressure is required. We can map it with the requirement that saves energy. And again, the same story, the reject management is also there, which again gives some value in return. We created a center of excellence. So any category of water we can deal and we can suggest remedial actions. This center is created at my university, which is Pandit Deendayal Energy University at Gandhinagar, Gujarat. Yeah. This is already in public domain, a lot of media coverage, TV coverage, everything.
I think part of this was already presented. Yes, thanks a lot. Sorry, because we are running out of time. And yeah, so see if online we have questions. See, before there were 2 messages, now there are 3. So, okay. So Professor Kumar that has raised his hand. Okay, so can we start from the online one? Do you mind, Professor Kumar?
Yeah, thank you very much. Like I was hearing it yesterday, I think there is a requirement. Also, government is looking at dual water supply in coastal areas for non-potable purposes. So where the salinity of brackish water, you want to bring it down to permissible level, and the dual water supply is being planned. With this, the stress on drinking water systems will come down. So the technology what you people are doing, can it be easily tweaked? And there is a very big market for this. That's just wanted to hear that. I wanted your reaction. Yeah.
Yeah, if I understood correctly, obviously there is a big market. The villagers, they count on the tankers only, and nobody knows from where these tankers are getting filled. They fill it from some running lake or somewhere. Or either they'll count on the rainwater only. They will collect all the rainwater in ponds and they will use it for drinking purpose for rest of the year. Sometimes when these gets empty and they are out of the drinking water.
Yeah, Professor Mudgal, if you allow me, maybe I didn't put my question correctly. Definitely the drinking water for villages and all is perfect. That's exactly one of the main ideas. What I'm trying to pitch for is a non-potable water supply in cities, coastal cities and towns, where the brackish water nearest will be picked up, where salinity, we bring it down to acceptable level. A dual water supply scheme will be designed. This is exactly what government is also looking at, an option. Just your quick reaction. There will be a very big market in coastal towns.
Dual water supply means I'm a bit.
It's a separate line. It will not be your drinking water line. It is a dual water supply. where it is for non-potable purposes, but the salinity, we should bring it down from your high, whatever the thousands into acceptable 2000 or whatever.
So this is for other purposes other than drinking.
Yeah, exactly. Other than drinking, all other things can be done. Other than drinking and cooking. India, it is a very big market will be there. People are looking at it. I just wanted to bring it to your attention of you and your team again.
True, sir. I believe that by using that category of membranes, which will even consume less energy, which will give more permeate flow at low pressure requirement, that can be done, and that is very much doable. So far, what we thought of for drinking water only, but yes, this is very much possible, sir. Thank you.
Thank you.
No other question online, so we go to the room. We have two.
Yes, I have the mic. I will ask a brief question. I'm Eric from the EU delegation in Delhi. Yesterday we discussed, I don't know if Mirko is there, IP, Mirko from Germany. I want to know how you are approached when you go to meet companies in the domain of IP. Do they ask you where you stand? Will you do it? Will you not do it? Where have you been? What have you published? Is it an element in your business model, in your approach to private sector? If you have generic information to share also with other colleagues, I am interested.
Yeah, thank you very much. I'll say that we have published several papers, about 20 papers at every aspect, in big and very good publication journals like Desalination. So, but still, at every stage there are some trade-offs, and this is very micro adjustment, very delicate adjustment to optimize the things. So that intellectual property right we are carrying with ourselves. The overall skeleton of the system looks very rugged and very simple, but yet to make it more economically viable, to make it more user-friendly, there are some small arrangements, which is a delegate arrangement, which is a delegate thing. But we are there to resolve it. And we have several companies who showed interest. Even we received interest from some overseas companies also, like South Africa and Brazil. They are dealing similar problems like India. So they are interested to create a system for some village community or some other scattered households, some 100 families, which don't have a proper solution. And the centralized system, they are far away from them. Even transportation cost, they cannot meet. And we are planning this is simply to move the piston. And we are very much focusing on to run it on renewable energy like steam. So if we have a steam by solar thermal arrangement, this steam is capable to pressurize the piston. So absolutely grid-free and electricity-free systems we are thinking for. This is the next stage. So we need volume only to pressurize the thing. This is not electricity. I mentioned it yesterday also. So this is my core area of expertise. So if we have that volume in any form, we can use it as a pressurizing agent. This is as simple as that. So a lot of avenues are there. It may take some time, but there are a lot of scopes.
Thanks a lot. We have another question here.
Yeah, hi, I am Parag from Italmatch Chemicals. I have one question on the membrane composition. Are the membranes which you are checking is polyamide membranes or any other composition? My question is more related to the fouling possibilities that over a period of time, these membranes will foul and the pressure requirement will change over a period of time.
True. So we encountered this problem actually. Pressure is the indicator. So to resemble it like fever is indicator that there is some infection in body and that needs diagnosis. So pressure is the indicator. When pressure, we observe that pressure requirement is increasing abruptly. So this is an indication that fouling has occurred. So we do acid cleaning And we have all the mechanism, established, the standard mechanisms established there. We did it and it worked. The pressure requirement again go down. So as and when we observe that pressure requirement is going up, normally we prefer to work between 10 to 12 bar. We don't allow pressure to go beyond 15, 16 bar. And when that point comes, immediately we go for membrane cleaning.
There any further question here? So thanks a lot to Dr. Anurag. Thanks,
Thank you very
Philip.
much.
And I will call the Pavitra Ganga people
Thank
for accompanying Mr. Anshuman.
Good morning. When the PPT gets loaded, let me first at the outset thank all the reviewers for the comments yesterday, and as well, Dr. Datta, for your observations today. While Dr. Paul Campling, gives the technology pitch, I thought it's a good time to again reiterate what we mentioned about the three pillars of the project, including the technology and the governance part. I think for the market mechanism for technologies to be upscale, I think this one major part which needs to be integrated in our plan, and something that I would request all the government representatives here to push as well, is about the 2 or 3 things which I mentioned, which I'll quickly repeat, which is policy guideline framework for identified technology for fit to purpose. Second is market mechanism, which is supportive for such technologies to be upscaled, which includes right from rational water pricing and wastewater pricing, as well as the recovery of the O&M cost and the capital cost. These are very critical market mechanisms which are required. And in that sense, funding support, subsidy mechanisms, maybe let's say rebates, etc. They all need to be thought through and put forth for such kind of innovations. I do want to also share with you all that as we moved ahead in the project, we made inroads and we involved all the key agencies, as I mentioned yesterday, including the National Mission for Clean Ganga and TERI and National Mission for Clean Ganga and NCG. We have already a center of excellence on wastewater, technologies, which is not just for the technology that we have initiated, but it's open to all the other technology that is possibly having a pitch or innovation which can be used forward. Along with, we are also, having a discussion with Ministry of Housing and Urban Affairs and other entities, including already some, corporates and industries who are actually on board to take forward some of this technology, and Paul will give you a glimpse of that. So we are very much looking forward to collaborations further to see that we are able to, take forward this technology. Paul, thanks.
Okay. Right, so we'll quickly go through the issues. Can we have the next slide, please? So we're looking in this project on technologies which are low energy and robust for secondary and tertiary treatment. And of course, we saw the issues around contaminants of emerging concern, so we need to have effective tertiary treatment technologies. So I will not go through all the technologies that we've developed during the project, but I will focus in on Andikos, the self-forming dynamic membrane, the structured absorbents, and the constructed wetlands. During the project, the exploitation has been a really important part. And we have identified the TRL level at 4, and we've made, during the project, looking at the piloting, going from lab to piloting, and then looking at the performance, reliability, and efficiency, and some of the coming up with the potentials and limitations of each technology. And we expect that after the project, then we would have to go for regulatory approval, scale up and manufacturing, and then marketing and sales. So the SFD MBR, as I said yesterday, is really an alternative to the conventional MBR. And we see that in the piloting, we have 10% less energy consumption in the filtration unit. We have a lower pressure gradient than conventional MBRs and a very low turbidity. So these are important outcomes of this technology. So we see it as the USP is the low energy system, which is applicable in centralized and decentralized systems. And of course, we have an industry partner already on board, Xylem, and they are promoting this technology themselves right at this as we speak today. And of course, within the team, we have the research and development support from IIT Kanpur and CNR. In terms of the Anticos, where we're looking at combining filtration unit with anaerobic digestion, it was very clear that the IBC membranes really perform well and they provide sewage infiltration for water reuse. And because it's a modular system, it's very, very flexible. We had slightly less returns in terms of biogas production from our system because there were changes in the organic content of the influent. We had lots of biodegradation issues. And of course, there's a reluctance in the Kanpur situation of mixing fecal and non-fecal waste streams. But we see that as in other situations, it could be much more a positive outcome. It's a net producer of green energy, and it, of course, reduces greenhouse gas emissions. So we see this technology as something which could be applied in new decentralized solutions. We have in the project Ion Exchange, who are also in the room at the moment, they are on board to take further exploitation pathways for this technology. And just briefly on the constructed wetlands, during the project, we've gone from TRL 3 to 6. We're using modified layers within the constructed wetlands, combining GAC with zeolites. And we've shown in the project that it's really good at removing trace organics and particularly this chromium-3, which is prevalent in Kanpur. So it's a polishing technology which has great potential in decentralized systems. In the structured adsorbents, we only really managed to do at a benchmark scale. So we weren't able to pilot it. So that's the next stage in that system. So this provides an overview of the different technologies in terms of where we got to in terms of the TRL. So of course, we would see that energy within the is an important aspect of the technologies we've been piloting. So with sludge digestions, we're able to produce energy. We avoid the burden of using northern grid, and we can actually do some co-digestion of the sewage sludge. So in summary, I think it's important to say that we're very close to commercializing the SFD MBR because Xylem already is promoting the technology as Taron. You can go to their website and see, so they're branding it with this name. We have Andicos on board to look at different new decentralized solutions where other organic waste streams could be used. CW Plus is, of course, is an open domain technology, so that allows it to be rapidly uptaken in the market. And we need to work a bit further with the structured adsorbents to show the outcomes in terms of piloting. So I think the last point is that we showed yesterday that the integration of technology and optimizing technology in all cases is really essential. Thank you very much.
Thanks a lot. So let's open the virtual floor first. If there's a question, maybe there is not. I see there are 7 messages, but I don't know if there are questions.
No questions at the moment.
No question, okay. Yeah, but I think it's the recording is thinking. Yeah. No problem. So any question in the room? Yes. Yeah, please go ahead.
Just as an add-on to what Anshuman and Paul already explained. So my name is Christian Katzner. I was part of that project team. The SFD MBR technology was not a xylem technology when we started the project. It was a technology developed by a small Italian SME, and we thought we would have a fantastic idea, particularly our friends from CNI Ursa in Bari. They've been developing that together with that small company, basically a steel company, which has the main competency in using steel in heavy duty applications like wastewater. And they got in contact, the company was called OMS. They got in contact with Xylem, and while we were running the project, they took it up, and then that led to the commercialization. So we were not picking big industries from the very beginning, but it was something which showed the relevance and the market importance and the potential of really innovative solutions. So just to clarify that and to avoid any misconceptions.
No question in the room.
There's a question in the.
I'd be very happy to hear something like a benchmarking of your technology with respect to the one already existing in the market, like your SFD MBR. What is the kind of pitch that you could stand? I guess you're looking at industrial effluent with particulates where you want to filter in. And in Andico is also some similar pitch so that, we can place it as to what would be your specific advantage over the existing technologies.
Yeah, for the SFD MBR, as I indicated in the slide, the consumption of energy is 10% of a conventional MBR. So that's already a very big USP for this technology. For the Andicos as well, the pitches for possibility of energy generation and conversion into electricity, but as well as filtration for fair use at a lower cost. In fact, Ion Exchange is already demonstrating this. They have a plant in Hyderabad, I believe, yeah, already, which is there open for anybody if they want to, go and see. It's already there, but we are further working to look into the nitty-gritties of, other contaminants and see how we can further optimize that. So you might have noted in our presentation yesterday, we are, because of the location where we were testing this, there was an issue of mixing the domestic solid waste. So, but that possibility is still there and the technology is very much there. So we are still able to demonstrate it at other locations. So that's something that we still want to pitch. Excellent, noted.
Christian, you want to do?
Yeah, I am. I wanted to add something regarding the SFD MBR. My personal background is mainly in membrane research, and we developed quite a lot of membranes in Aachen University, where I used to work. We were kind of the leading group in membranes. And compared to the conventional MBRs, the rotating meshes, basically it's a screen system which is rotating with some kind of screening system where you produce that cake layer. And that is just submerged like a conventional MBR. But the current limitation in terms of upscaling is basically the size of these screens. And Xylem is currently upscaling it to larger degrees. So we can even build large, 50 MLD or even larger plants with this system. So it's not only for industrial applications. You can really use it for domestic wastewater treatment, for more compact STPs, particularly in urban setting, similar to, let's say, SBR like CTEC. A similar setting is foreseeable for this. And I think particularly with the focus on reuse, it's an excellent technology with a very low energy footprint, a low footprint in terms of size taken, which is becoming more and more expensive. So I think there's a big market potential for this technology in India.
Just to supplement,
check the website and what the Xylem has on stock currently. So it's fully available. It has competitive performances. So I'm not working for Xylem.
Me neither, but just to supplement, the usual, membrane pore size around 0.1 to 0.01 range. The SFD MBR basically is through the K clear, using around 5 to 550 micron. So that's the pitch where we are able to reduce the energy consumption. So just to can share with you.
So thanks a lot. And yeah, we have the last presentation now from the Spring people, Professor Kalai and Dr. Nagesh. Not sure. I am.
Let's wait for that.
Good morning to all. Myself Sanjukta here, and with me will be Gyuri and Nuno to present the technologies which has come up from the Spring project. So to come up with the first one, this is a methodology which has been developed for monitoring the river systems for point and non-point identifications. That is number one. Number two is the enzyme xanthine oxidase. Yeah, okay. Yeah, so I'll just start it over again. So, okay, so this is a second thing which we have come up with, which is a xanthine oxidase enzyme in a purified form, which is available, which is available in almost 1/3 of the cost. We are still scaling it up. This is the prototype which we have developed, and this has 6 different sensors. Which is mobile 6 different sensors, and it is like you can access the data from anywhere, and this has and you can scan the QR code with which you can access the data, any one of us. So it has been supported. It has got an R&D support from the Wind Foundation as of now, and it has won the best product design at the Vishwakarma Award at 2023 IIT Delhi. So this is what it can address. These are the different municipal wastewaters. It can address river system monitoring. It can even address consumer water supply things. And the cost, as you see here, it's a 3D printed thing in our lab with a PLA, so it's biodegradable in nature. And it costs just 12,000 in hand. This costs 12,000 in hand with 6 different sensors. And this is a market search which we had presented, like where do we see the market and what is the type of competition here. So this is the entire thing about it. And this is a video which we have, which I'll not play. Ever pondered? Sorry, if it is required, we'll take it up after this. So now I hand it over to Nuno. No, but it is after that. It is after.
Okay, so good morning all. I'm talking here about the technology that we've developed to take all the sensors and that we developed in the project and transport them without anyone being needed to go there. So the idea is to have a robotic boat to carry those sensors. We can program the mission, and the vehicle will go automatically to a position or scan an area, or if you need, you can also use a joystick to manually control the vehicle to take that. So the idea is not only to replace the operator, so we don't need anyone to be in polluted areas and repeatedly doing some survey, but also the added value is that you can integrate all the data into a single system. So you are, at the end of the mission, you have time, position, and data all synchronized automatically. You don't need people having GPS position and all the time and so on. So we developed a vehicle that's quite large. So it's about 100 kilos, but it's good enough to have a large system for as we will see from other partners, to test the water quality, also to provide enzymes to locations. Another partner of the project that developed. So we actually have more information. I'll hand out some leaflets that we have during lunchtime. I can hand out some more information about this. We think we are in the TRL 7 at this point. We are doing some tests. The project is not finished yet, and we are then progressing to a business plan and seeing what is the market for this. Okay, thank you. Yeah.
This is the robotic system which has been developed by DY Patil, and the robot is ready. Sorry. The robot is ready, and it can detect blocks in pipes ranging from 30 centimeter to 1 meter, and it is adjustable in nature. It can not just detect the leakages, detects the blocks. It can cut those blocks and bring it out, and it can also deliver the payload. So this is a developed prototype. So it's almost in TRL 6 to 7, we can say. This costs around 4.5 lakhs for 1 unit. So when we scale up, it will go down. Next.
Yeah. Okay. In frame of the project, we also developed another sensoric unit. Practically, this is based on the microbial fuel cell technology. This technology is not pretty well developed this time now, but we have made some progress in order to make its function much better. So this microbial fuel cells actually works with the presence of special electroactive bacteria. And we have to know that the function of these bacteria is proper when the system is anaerobic. In most of the monitoring system, or during the monitoring of water samples, these anaerobic conditions can be assured. So we have developed special pretreatment methods. By these microbial fuel cells could be work more effectively, and by that monitoring of the biological oxygen demand and toxic conditions of the water can be performed. So this box that was also taken on to the boat system, and that you could see looks out so in the middle actually, and this has several units that by that we can use, how to say, long-term monitoring of water samples in these conditions that my colleague already showed. Yeah.
So one of the last things, one of the last things as a prototype which is coming up is the advanced biooxidation process, about which Dr. Sharath as an SAP partner will be talking about.
So actually, the final objective of Spring project was to come out with a smart biooxidation prototype, which can work both in remote as well as in standalone units. This is for remediating the smallest pipeline, like a household sewer, to a large river or a lake. So in front of you, you can see the prototype, which is a working model, and this has been tested in a household drain. And this can be scaled up. This contains the sensory units. Right now, the sensors for water quality monitoring has not been integrated. All these things will be integrated in the next 3 to 4 months. And this sensor, once the prototype would be actually put onto a boat and used as an unmanned autonomous vehicle. So this will have the sensors, not only the sensors, also will have the software where you can sit at any place in the world, operate it either through your laptop or your mobile. It will give you data for a particular hotspot or different spots where we have get, so that you can get multiple data can be accessed almost all through the year. So we can get water body health. We can decide to what factor we need to do the bioremediation. And the major objective is to bring down the footprint of any water treatment plant, especially in industries and all, reduce the water electrical or the power consumption, and give a very compact system which can use. For this, we're utilizing the biooxidation, that is the enzymatic release of hydroxyl radicals, which will not release any chemical, especially moieties, metal moieties and all. So it's completely contamination free. And the enzyme is recyclable for almost 100 times. We have tested up to 60 times in the lab, and we got repeatability of around 40 cycles with domestic sewage. So we're trying it out with certain industrial effluents. Right now, we tried with pharmaceutical effluents, which are very hard to degrade. In the coming 3 to 4 months, we'll have the final prototype, one worked in the industry, and all these, we'll have around 6 to 7 prototypes developed, which will be installed in the hotspots, which we have discussed yesterday's meeting. Thank you.
Online questions? Yeah, because there are 10 messages in the chat, but maybe there are no. Yes, Professor Kumar wants to speak.
Yeah.
Well, then, Professor Kumar, up to you. And then we have a question in the room. Kumar first.
Yeah, thank you. I think, thank you. Very nice presentation. A lot of gadgets being prepared. Though there are a lot of applications, one of the things I'm looking at, the lakes, a lot of lakes are, water bodies are quite polluted in India, though we wish it is not to be. But do you see a lot of major role, not only in monitoring and then partly cleaning up of these water bodies?
Yeah, so to this, we have to add, actually, I have not presented the data. By now, many lakes have been cleaned up in the Haryana region and also in the West Godavari Delta region. In cities of Hyderabad and Vijayawada, many different lakes have been cleaned up by us now. So we will be bringing up all that data maybe in the next review. We have all the data for that.
Oh, in fact, that if it was put, it was really very good because many of the cities and towns and things they are looking for solutions in maintaining this lake water bodies as clean. That gives a great opportunity for these municipalities and other things. Thank you.
Actually, I started exploring and doing works on the lakes. We did around 10 lakes in Hyderabad. So we also have solutions for water hyacinth and other weeds, which are a major problem in most of the lakes because of contaminated lakes. So we are addressing both these solutions. And I want to add a small thing if we have some time. Wherever we are looking at remediation of lakes, we always look into the nutrient removal or the color removal, odor removal and all, and make the water clean. But we have witnessed people being very happy, especially we have case studies in Hyderabad where people used to spend around 3 to 5,000 rupees per month on controlling mosquitoes. Leave apart the respiratory diseases. We were working on a lake called Kudikunta in Hyderabad, which is in a very prime locality, which was just located by a very premier community of villas. And like we were surprised to know that around 5 to 6 deaths happened in due to dengue, and out of these 5 deaths, 3 were 3 days were of actually people belong to the very high society, especially they were at a higher level in the government. So then once we did this lake is now pure for more than 3 years. They didn't take it further, but we maintained the lake for 3 years. And the feedback we get is like less respiratory diseases, especially people had a lot of asthma and other diseases. Then we had one second. And mosquito menace is not there. And even the total net spending is reduced by all these families. This is the most like cost advantage which we saw.
Thank
you. Yeah, this is an extension of what Professor Mohan Kumar asked. I think both of us try to, help our cities in advising as to what to take and what not, especially in technologies. Your technologies are quite promising for us. That's why our interest. But what I didn't see is your very strong numerically based selling point on this. Say for your talking about pipe cleaners, such things already exist with water jets and remote cameras and all that. So we didn't see how your technology would be better. 1 minute before you answer. Second, you talked about the MFC-based BOD on-site thing. How long it takes and what is the advantage it would help us to, again, monitor lakes, which part of the lake is polluted, if it can be done very quickly. And last, again, the same thing that the boat kind of things is already available on sale. So I didn't see how your boat, the one you're making, is better, especially in a very shallow water where we have a lot of weeds. Conventional propeller-based propelling system is not going to work. So do you have a water jet or some other propelling system which is independent of? Can it go on a lake with a lot of weeds? So this would be actually your selling point. And if you have some indication, that would be really great.
Much. Can I start with the boat? So if I can start on the other way around, so on the boat. Actually, I didn't go through all the details, but the thrusters are two things. So the thrusters can move up and down, so we can install them for shallow water. We can move them up and down, or we can replace for different actuations. So everything is modular, so we can replace with a specific scenario. For our case, we start with what we had in mind, our target. So this is good for the scenarios that we were trying to test. But I agree with you. So we can change it or adapt it to specific things. The same applies for the sensors. So as I said before, and this is actually a challenge to the other projects, because we have a chance for cross-fertilization between projects, because we are happy to integrate any other sensor from other projects into our boat to test how we can work with other systems, because the boat is a platform just to take the sensors instead of people getting that water, and avoids people being, in bad situations for their health. Okay, and I don't know about it.
Actually, yes, sir, I have a little submission for you. Actually, this boat was intended to carry the payload or the sensors only as a part of the project, sir. But rightly, as you said, and rightly, like what we have worked in lakes, we have this water weeds and all. So for that, there is one, we are actually looking for an opportunity to have a cutting system, especially for the weeds, water hyacinth and all. The boat can't move, sir. Not even a propulsion system. We had a 10 HP boat, which we tried to move in one lake in Pragati Nagar in Hyderabad. So I had 10 people just only removing the hyacinth. So what we did is we made another shaft with a motor which cuts the hyacinth, breaks it out. Because there are systems which will actually take out the water hyacinth and all. But again, these systems are not working. But by the end time, it takes 4 to 5 days to clean one part of the lake. The other part of the lake, water hyacinth comes. So what we are doing is to use our enzymatic and for other systems so that the weed is killed and it is digested there. For this, yes, sir. This boat also, we have to increase the size of the boat and have an add-on so that it makes its way through the weeds and also.
Nearly half an hour. So this is the response time of the MFC sensor now, yeah? And the problem that want to reflect that longevity of the system is very crucial, because in the special conditions, when we monitor natural waters practically, we have to defend the bacteria themselves on the anodic surface. And for this purpose, we developed such a system that, to help the longevity of the system from that point of view. Yeah, protect other bacteria from outside to colonize the crucial anodic part of the system. Yeah.
And regarding the robots, sir, I have the last question has to be answered. I'm sorry. Robots are there, like especially these are to monitor the underground pipelines and all. Why we took this robot up as an additional thing is the water jet systems and all which are there. We have practically experienced working in one whole division of Vijayawada. So water jet only makes a small orifice through the blocks, sir. And within a few days, again, the blocks go down. While we were applying enzymes, like I was doing with raw enzymes, we did it for Vijayawada through the government of Andhra Pradesh. So we found that there is almost around 1 to 2 inch layer of oil and grease that we call as a fat bug. It is the major cause of a block. And apart from that, the plastics and all thrown into the gutters, actually the organic matter decays and then it sinks into it and forms a block. So what this enzyme, the hydroxyl radical does is it digests all the organic matter within it. And also we found chunks of this fat bug being removed and the pipe diameter, effective diameter has increased. So the only disadvantage with using raw enzymes, free enzymes was to use a lot of enzyme, that is wasting money and all. So using this immobilized system, actually the same payload, we have an immobilized column at the rear of the robot. That is the intention of developing this robot, sir. This is the USP. So the robot goes, detects if there is any physical block like a stone or roots or plastics and all objecting it. It will do that. The remaining part will be done by the enzyme. So the enzyme system will take care of releasing the hydroxyl radical, break the organic matter. So this will work, both will work in tandem. That is the major objective of taking up this report, sir. Thank you.
Thank you. We have a very last question for a quick answer. I need to ask you because we are super late. So
Yeah,
quick
thank
question
you.
for a quick answer.
Very nice innovations. I'm Miraj Ahmed from GIZ. I'd just like to know this advanced biooxidation system, which you have presented, that will be installed in the drains or in the ponds. Now, looking at the interventions these days, most of the STPs under the Ganga mission, Clean Ganga mission, which have been constructed, they are based on the interception and diversion of drains. So there are also some bioremediation were done earlier and some are being taken up. But we encountered that a few have failed also because of the fluctuations in the nature of the influent which comes into drains. Sometimes the chemicals from the drain industries, they also add up. So how far is this enzyme-based system application and treatment address these changes and the fluctuations in the influence?
Yeah, so to address this, what we have to say, you are very right. When we talk about discharge points, we do have to address them at the confluence of drains and canals. That is why we had come out with the study when with respect to our study area. So that is one thing. But this also does, as we are saying, that we are also trying to monitor the pollutants first and then decide what will be the strategy to be taken up. So that will help. And we understand whatever difficulties you are putting across. With regards to lakes, we had success. Stagnant water bodies are easier to treat. But when it comes to water bodies which have discharge points, it is a discharge points which have to manage fast before remediating those points. Thank you.
So thanks a lot. Bertrand, you can come for the next section. I have just a short communication concerning the presentations. Please let us know if we can share them through your access, if you have your concern, because you might have issues. So you let us know.
Thank you.
Okay, thank you very much. We will now move to the session 2. We will first have an opening remarks by Laura Sustersik. I don't know if, Laura, you're online.
Unmute. And can you hear me?
No.
And can you
Yeah.
see me?
Laura, we hear you very low.
Okay.
Yeah.
Can you see me?
Yes, we can see you and
You can hear me
we
very
can hear
low.
you.
I don't know how to address this issue, to be honest with you.
No, this is perfect now.
Okay, good.
We can hear you. Laura Sustersik is a GIZ project director from the support to Ganga rejuvenation. She has more than 20 years experience in water supply and sanitation in Asia, Africa, and Europe. She works in India since 2018, where she was involved in the India-EU Water Partnership. She holds a water resource engineering and management, a master in water resource engineering and management, and a diploma in international environment law. So, Laura, without any delay, please.
Thank you very much. I will try to share my screen. I hope it works. Please do let me know. This one. Let's see. Share. Please let me know if you can see.
It's coming. Yeah. We can.
So now I should share in presentation mode. I don't know what happened. Are we there?
Not yet.
It shows to me that I'm sharing. Otherwise, I'll put it back in.
Yeah, you're sharing, but you're not in presentation mode. We can see the. We don't see the presentation mode.
You can see the presentation. You know, maybe you can see the screen like this, right?
We can see the slide. If
I think it's better we leave
no.
it like that because it's mixing
yeah,
up.
okay.
No,
Yeah,
kindly press the button next to that percentage, left side, at the bottom right. Like
Here
a
you
cup. That one. Yeah, please try that. Yeah.
I pressed that, but
Oh, okay. Then
I
leave
pressed
it. Okay.
it, but you couldn't see it. You see,
Okay, fine.
something happens and you can see it. So I think we leave it like that is better. So thank you very much for this opportunity. I'm really glad to be here. I followed with much interest the presentations before us about all this technology to support water management, especially cleaning of polluted water. It's really exciting to see how much research went in that, but I will bring you some, let's say, a bit critical comments, not in the technology, which is there and it's great, but the market uptake. And they are, from our experience, that's really the crux of the matter. Wonderful research is done, wonderful technology is available, but then bringing it really to the market on a larger scale, it's quite complex. So we have, let me say first a few words about the India-EU Water Partnership action. So this is a water partnership that was signed between India and European Union already in 2015, I believe, and a project to support implementation of this partnership was established in 2017 and is co-financed by the European Union and by the German Federal Ministry for Economic Development, with the aim exactly to strengthen technological, scientific, and management capabilities in India and in the EU in the field of water management. And the project has been working on 4 pillars: river basin management, excuse me, irrigation and efficient water reuse, environmental flows, and safe reuse of treated water. And supporting these 4 pillars as a cross-cutting activities, the project has been flagging business opportunities to the EU businesses in the Indian water sector through a series of activities, which included webinars, hybrid events, roundtables. And this was, was preceded by a good and quite thorough study that we carried out with the project to understand which are the hurdles that businesses find when trying to enter the India water sector, which is really what is the topic of the conversation today. So from the feedback that we had with talking to several European companies, both based in India and based in Europe, that have technology that can really address the issues. But the feedback we had from companies was, you can see it summarized here, one of the main problems was the heterogeneous governance system in India. Now, you know that water is a state issue. So states, according to the Indian constitutions, are the custodians of water. They are the ones responsible for management of water for activities, but there is also a central level, federal level of responsibility, and then municipalities are really implementing activities, particularly for water supply and wastewater and sanitation. Excuse me. So this complex system of different layers is quite difficult to navigate for companies, especially if they are based in Europe. The second point was the reliable access to relevant information, projects, tenders, actors, and institutions. So there is generally not one central repository of tenders where companies can look and understand, okay, there is a tender being floated in Tamil Nadu or Uttarakhand or whatever. Often tenders are floated on local newspapers and sometimes also in local languages, and this really creates a barrier. Or there are central websites that have some tenders, but not complete information. So it's quite challenging for companies from Europe that don't have a support in India to understand which tenders are coming out. Then the procurement procedures. Very often tenders have got this L1 criteria, that meaning the cheapest offer will be taken up. And we all know that technology, especially technology that comes from Europe, tends to be more expensive. So if we only have the criteria on cost, this almost automatically excludes European technology. So the effort should be to have criteria that go beyond simply the costing of the project, that include operation and maintenance or technical criteria and technical specifications. And transparency in regulations and processes obviously is also a point. Challenges with the project financing models, tenders, and other risks. Yeah, this goes together with the little bit of issue of transparency. It's a very complex environment that is not easy to navigate for somebody who has not much experience and points of contact in India. So to address this, the project is working on establishing what we call solutions forum, which should be a platform that brings together the main players that will enable implementation and uptaking of technologies, market uptake of technology. And so the main players sitting at the round table should facilitate the implementation of program of measures. So the project has developed a river basin management plan for one major basin in India that is called Tapi Basin. And this basin management plan includes a program of measures that is a list of projects that should be implemented to improve management of the river basin. So this is a wonderful step in to allow entry point of appropriate technologies, because would offer really practical implementation projects that are discussed together with the Indian partners and are wanted, let's say. So this would offer a wonderful platform. So we would have facilitating the implementation of the program of measures and matching with relevant technologies that have the capacity to address the issues that are in this river-based management plan. And of course, facilitate adaptation of innovative products, showcasing European technologies and facilitating knowledge transfer. So the idea is, how do we bring technologies to the market and to the implementation? And since the project has developed this plan, this is a platform to bring together technologies and project developers and also projects implementers, let's say municipalities or departments of water resources. Let me come to the next slide, and that's exactly, you see the stakeholders on the solution forums. That would be financial institutions, research institutions, bilateral and multilateral agencies, the Asian Development Bank, World Bank, just as bilateral supporting agencies, the implementing agencies. That's a key player in this solution forum, municipal authorities or state authorities. In this case, the Tapi Basin administrators, and of course, the industry associations from EU member states, etc. Let me give you this comment also. Something like this does not exist yet in India, and as far as I know, also not in Europe. In Europe, we have another way of going to implementation of technologies, and in India, we have identified this lack. So this is really a pilot project, or let's say a first attempt and trial to bring to the table all involved key stakeholders, and to provide also with this program of measures and the river basin management plan, which has been adopted by the states in the TAPI, to provide really practical applications for this, a possibility for practical application. So it will be quite innovative. You see here the technical, the scope of work for this solution forum would be the technical support, so the supporting of development of bankable projects, identify and facilitate access to funding. And we are thinking here funding from national sources as well as international, as I mentioned earlier, bilateral and multilateral development agencies, but also to facilitate convergence. There are in India so many missions exactly tailoring and tackling the issues of water, climate, rural development, environmental protection that can be sourced and to implement measures, in this case in the Tapi Basin. And very often we have heard that capacities are lacking to develop project proposals. So on one hand, finance is available in India. India is a rich country, doesn't really need bilateral, multilateral banks, really. There is a lot of effort from the government to tackle these projects, but very often the absorption capacity from municipalities is limited. So that would be a key point to facilitate, together with the identification of technical solutions. And you see this also here, as I'm saying, the rising of capitals and the convergence. I was mentioning Indian missions. In India, they're called mission schemes. And you can see here how many missions that are relevant to the management of water and environment and climate change are already existing. So there is a lot to be done and a lot of effort that we can support with municipalities and state departments. Financial institutions that are active also, you see just a selection. So we have had extensive discussions with the stakeholders, and we find much interest from the Indian side, much interest from the Tapi Basin to bring the solution forum into life. So we are right now in a moment of transition. The project that just ended, we are starting the new phase on the 1st of March. So we'll be very happy to report back as soon as we have the solution forum working. For the roundtable discussion, I have my colleague, Dr. Vikrant Tyagi, sitting in the audience and will take part of the discussion, since unfortunately I cannot be there, but he has been the institutional memory and the main motor behind this whole development. So he'll be able to represent us wonderfully. Thank you.
Thank you very much. I just have, it's striking to me when you expose the differences, because when you see what are the differences, if I look at heterogeneous governance, reliable access to relevant information, complex Indian market. You also talk about challenges of languages. I think we are a bit the same in Europe. So it's interesting to see that we have the same hurdles, and that the action that we can jointly do here in India can also benefit from for the access to the market in Europe.
Yeah.
So thank you, Laura. We have your.
I have a question. I'm trying to. Do you still see my screen? Okay, now.
Yeah.
Did I stop sharing? It's okay now?
Yeah, it's okay.
Okay, thank you.
And I think also the platform that you mentioned is a very interesting tool. Did you, if I may question, did you have contact with the Indian authority? What are their feedback on the project? Do you have a plan to put this forward, and which is the time frame?
Yeah, absolutely. The partner for the project is the Central Water Commission, which is an institution that depends from the Ministry of Jal Shakti. So they are the partner, and the Central Water Commission is the chairman of the Tapi River Basin Management Committee. And other members of the committee include representatives of state departments that are relevant in this case, water resources management or irrigation or drinking water supply, depending on the 3 states. So Tapi Basin includes Maharashtra, Gujarat, and Madhya Pradesh. So we have representatives from the 3 states and from the central government. We have discussed and developed this concept with them. The next step is really bringing it into life, and so bringing it much closer to the state. So we are now in the process of discussion, should there be one representative in each basin state, or at least one representative in Gujarat and one in Maharashtra, being these the two states that have the biggest chunk of the basin. And they are, Gujarat is obviously highly industrialized, so there is a lot of industrial water pollution problems, and Maharashtra is highly agricultural land, so there is no point source pollution in the river. So they are in the picture, they are on board, they are part of the committee, and this concept has been developed with them. Timeline is, as I say, the project will start again in March with the first activities, and we have a timeline of 3 years, and I hope by the end of 3 years we will have a up and running and working solution for it.
Okay, perfect. And I think our project would be very good example to feed the platform at the first stage. So this is very good. Thank you very much, Laura. And I leave you to your duties, and we will continue the roundtable. So I will just ask. We have 2 participants online. So Peter de Jong from WETSUS and Kuldeep Singh from Micro Transmission System. Are you connected? So Peter, I see you. And Kuldeep Singh, I see your name. Yeah. And I will ask Praveen Gaikwak to come on the scene. He's with us from Xylem company. So we heard about Xylem previously. So this will be interesting. I will just, you can go up. I will come with you, not to leave you alone. I will just have a Vikrant, if you want to come also to represent GIZ, so the question can be directed. And I will ask Vivek how much time we have more. Okay, perfect. Thank you. So we will have a good discussion on this. So I will just first ask let me check my notes, sorry. Just ask perhaps first feedback. I don't know who like the people present attended to the pitches, but I don't know online if you managed to follow all the pitches. If you could have 2-minute statements on the level of development of the project that you had, and what you may see as a potential for the development. So I will start.
Yeah, thank you. Good afternoon, all. I think the project we have undertaken with respect to MBR, that is, we call it as a Taron, is actually in advanced stage of demonstrating as a technology which is suitable for the Indian market, and as well as it's more or less bridging the gap between what membrane-based technologies and other activated sludge process technologies are actually limiting to that particular market segment. So it is kind of developing a new, I would say, potential segment, okay, where the non-potable or non-recyclable, when I say non-recyclable means using RO membrane kind of a thing, where you need a high degree of a pretreatment. It could be the replacement at that particular segment.
Okay, thank you. Perhaps online, I don't know, Peter, did you manage to attend some of the presentation? I know you were connected at least at the end. I don't know.
Thank you. Yeah, good morning, everyone. Or actually, for you, good afternoon. I have been present a bit before this session, but I haven't seen too many of the presentations. I did see some of the hurdles mentioned. for entering into the market. I don't know if this is the right moment to step into that, but for sure, for many innovative SMEs, it is it's not easy to enter into the Indian market. Later, also have an example of a company that did manage, but yeah, one was mentioned is the cost. The other one is indeed the partnership that is required, and especially for SMEs that maybe have 10, 15 people staff, that is quite complicated. Regarding the projects, several interesting projects have passed by. Yeah, and for instance, the autonomous boat, indeed, questions like would there be too many plants in lakes, and therefore could these boats better be propelled by jet propulsion? I think those are also relevant questions if you look to lakes in European waters. But I haven't seen too many of the other presentations, so I cannot comment more. Thank you.
Okay, thank you very much. Perhaps in the room, we can, if you want to make a comment.
Thank you, Bhatto. So from yesterday, we are listening to all the recommendations of the Horizon 2020 project. And means I can say the problems which Indian water sector is facing right now, or the major attention on means of the government of India on the Indian water sector actually are on these two areas where recommendation from your joint work is actually will going to create a change in a means a paradigm shift will be there if all the recommendations are being thoroughly adopted and applied to the Indian water sector. So the only thing is how we can facilitate this thing, because it is not like that, as Professor Chanakya has mentioned, that sewage is being used from last 1,000 years in India. And so there's a continuous evolution is there. We are moving towards improvement. So no system is, we can say, okay, we are at a level of system where things cannot be changed, or we are on a final stage. So there is a need of continuous improvement, and it required consolidated efforts from all the stakeholders. And how it has to be taken, it has to be discussed jointly with the EU and the Indian water authorities. And involvement of businesses is important, because the scale on which profits can be made could only be possible if this invention or recommendations are ready for commercialization. So that's why importance of business is there, and all this need a facilitating environment and a positive attitude that where we are saying, yes, let's pick a pilot, or let's take a diversion from the business as usual and think outside the box so that a solution can be provided. And I thank you, this listening all of you was a wonderful opportunity. And as a GIZ and a part of India Water Partnership Action, we are here to support the process, and we will always be there. Thank you.
Thank you very much. Also, Kuldeep Singh, if you did you manage to attend the presentation before, or were you only able to connect lately?
Yeah. Good afternoon, everyone. Actually, I have my other experiences in the development of new technologies and for Indian market. The adaptability challenges actually we faced. We have developed a system or equipment for sludge treatment, sludge handling unit, the screw press. Actually, the Indian market is accepting all the technologies from overseas and Indian also. But the challenges of these technologies, new technologies, because there are available technologies which the Indian industry or the departments are using, is a very feasible for them. But new technologies has there some other concerns and operating issues also. We have developed a sludge handling unit, and we have given to the IIT Roorkee for the performance evaluation. After that, before going to the commercialization of this product. For commercialization challenges, actually, the Indian market is available other centrifuges and all for the sludge handling unit, but the screw press is new for the market, and the industries or the counterparts are using them, the centrifuge. So they need a piloting one. They need the pilot instrument, pilot product before the using for the commercialization. We have given to the a CETP in Uttarakhand also with the GIZ also, and after the performance of that machine, they will purchase it. So that's the concern. Actually, we are working on 2-3 other products also. The adaptability of this new technologies is the performance. They are not going, the Indian market is not going to take the new technology before they are not getting the performance or trust. So I think before going to do commercialization for the any new technology, they need some performance supports and the trial one also. Thank you.
Oh, thank you very much, and thank you for your experience. Yeah, I didn't introduce you, so you're working from micro transmission systems.
We are working. We are into the manufacturing of process equipment for sewage treatment plants and ETPs. Yeah. And we are mostly enlisted in the every Indian departments for water and sewage equipments.
Okay, thank you very much. So now I will ask, because we have good company, so Xylem, that is present on the scene. So you are present in India, and what is your experience in trying to access the Indian market, and also what kind of difficulties did you face, and how did you manage to come up with this?
Yeah, I think it's very difficult to summarize the journey of 13 years establishment in a few statements, but I will try to say elaborate a little bit. See, whenever we talk about the technology, one thing is the application of the technology, which is matters. And when you have a strong application range, then it's easy to say present to the customers or the possible buyers. Then the next thing comes is about differentiating yourself with whatever available in the market. And that differentiation, it may be with respect to capital cost, footprint, investment, and operating costs. So once you create an impact with a product line, then again the next step comes with and which is again a egg and chicken story. Whether I should invest and then develop a market, or there is a already developed market, how do I do that? How do I project my product? But in I think company having a well strategy always think of a long term and thinks about participating in the growth of the company. So same thing is happened with Xylem. Xylem has invested in India with a vision and having their say factory at Baroda and corporate office at Bangalore, and the treatment division is with respect to core water treatment or wastewater treatment, which is in Mumbai only. So we are currently executing 3 big STP jobs for Mumbai Municipal Corporation. So we do face a lot of resistance in initial period. See, placing your product with whatever be the European or North American mindset is not going to help. But so it is necessary to update or to project in a market about the product. And then when you want to have a penetration and a significant amount of footprint inside the market, I think localization is the key. Okay, so that's why I just explained that we have our factory in Baroda also. So be part of the growth story for the country where you want to do the business. And I think that will give a success. And yes, Xylem is on that path.
Yeah, thank you very much. I think this is also what we try to address with the project. So to have a technology transfer and to be able to find ways of producing these products in India. So there is indeed localization of the market.
Yeah, and in fact, we started with a partial and some products on completely localization, and so, I would say that most of the segment we are trying in a treatment part, that how we can shift from say sourcing from global growth centers, rather from global centers to the local Indian city.
Thank you very much. And yeah, no, it's and I will go also to Peter. So Peter, is you have you said previously that you had some SMEs that managed to come in the Indian market, and because you're let's say you're it's not a company, but you're yeah, well, you will explain what it is exactly. Your group, Wetsys, you are trying to help companies to integrate in the EU market, and you have a specific setup. Let's say, can you explain this a bit so we can see whether there are things that are interesting and common with the Indian market, so you can these can be transferred also.
Yeah, thank you, and thank you for inviting us. Yeah, so I'm representing here the Technological Institute Wetsys. We are a European Center for to develop sustainable water technologies. We've been established in the year 2003 as a regional center and slowly grown to have a pan-European collaboration orchestrated. We are in a region that itself does not have a university, but we managed to connect with 52 professors from 9 countries. They bring all their knowledge to our center. In our center, we work with companies that would like to bring new technologies to the market. So the research can only be done if there's direct interest from at least 2 companies per research topic. In total, we are running 20 different research topics, and they are being executed by 65 PhDs in our own laboratory. The more than 100 companies that collaborate, they are from all over Europe, but they're also from Canada. They're also from the United States, Middle East, and Asia. And among them, also, we have a member from India. The Tata Steel Group is one of our members. They're not directly involved in one specific research topic, but they're a member of the overall network because they would like to know what is the latest developments in the field of water technology. To name a company that is active in India itself and member in our research program, would be Unilever. You might know them as a Dutch-Indian company Dutch-English company that recently became more English than Dutch. But their research lab on water, if I'm not mistaken, is located in Bangalore. They are involved in our research program. Another company that is active on the Indian market that is a startup from the Netherlands is a company called Annex Filtration. And they develop direct nanofiltration membranes. And their system was installed in the CETP Jetpour company, in which they recover caustic stream from the textile industry. And they partnered with an Indian company called Aquarius H2O Dynamics. To give an example, that sometimes startups are able to be of the significant size to make significant steps into the Indian market. But for most of the SMEs, it's still rather complicated. The topics that we are addressing are like decentralized wastewater treatment plants, phosphate recovery, various topics in the water technology field. We're active in many EU research programs, and we look forward to collaborate more on a pan-European scale to begin with, and of course also with more international partners. What is in our case key for the success is that indeed from the beginning companies are participating in the research program. So any scientific outcomes that are being produced can be taken to the market by them. So far, we've developed 100 patents and 50 spin-off companies, indicating that, yeah, that a lot of our research is able to make it to the market. And generally, next to WETSUS, we also have a cluster organization. They help these companies to go to the world stage. For instance, international trade fairs on water, but also recently again in the CES in Las Vegas, a the electronics trade show, in which water technology companies are able to showcase their contribution to sustainability. There are also some initial inroads into India, and hopefully more can be done, and yeah, more can be developed together. Thank you.
Thank you, Peter. I will come back to Kuldeep Singh. What is your experience with the innovation? So bringing innovation to the market, and let's say, did you face any difficulties or hurdles with the implementation of this solution on for you, the water market? So to have a bit more insight on how the water market in India can work.
Yeah, sure. Actually, once we have developed this system, the screw press and other equipments, we generally give the machines for trial run for the industries which are required these system. Initially, we have given the trial machine to understand the machine, to understand the technology, to understand the performance and the and the positiveness of this technology. The profits which by which this using this technology they will get, and after the performance, after getting the performance, clients or customers will get this technology. Every time, each and every time, initial days, now it's working fine in India market. But initially for the industries, they always take the trial run, and after that they will take the machine in commercialization. And for the government departments like municipal parties and the center water for this Jal Nigams and the water body water departments like Jal Nigam, UP Jal Nigam, Gujarat Water Supply Sewerage Board, they actually need technology enlistment in their departments and the tenders as well. If the technology is approved by the departments, and that name or that technology into the tender itself, then customer or contractors can take this equipment. So we need to focus for new technologies to adopt the market, to get into the tenders for the government departments, and for industry we have to put the trial runs first, so that customers can understand the positiveness and the general awareness of this technology. Sir.
Thank you. So yeah, it's echo quite well what was presented by Laura at the first stage. Perhaps we can start with a round of questions in the room or online if people have questions for the panelists. So not in the room. Is there any online?
Yes, there is one online question from Mr. Karunendra Singh. I have a query to Mr. Kuldeep Singh, that how much of your machine differ from the machines which we already have on the market?
Actually, generally in Indian market, before this 17 or 2017 or 16, we are developed the screw press. At that time, most of the clients or most of the departments are using the centrifuge, decanter centrifuge. And for decanter centrifuge, everyone is feasible and everyone is very familiar with that technology. We have developed this screw press, which is called also Evolute. And we have taken this machine into the market. Everyone after giving the performance, everyone is ready to take in industry segment. But in government department, we face the enlistment in the tenders or make in the tenders after everyone knows that this technology is very much good, because this screw press is taking very less energy consumption as compared to this centrifuge, decanter centrifuge. But in the specification in the tenders, they want to take it, but they are not. They are bound to take the specs in the tenders only. But we face most of the time in tenders only. For industry, we can you can give the pilot run, and they after they will satisfy the performance, they will take it directly. But in tenders or in the government departments or government sewage projects, municipal projects, you have to put into the specification before the tendering process, and you have to be justified before tendering only. If your name or if your technology in the tender itself, then you have to take the commercialization of this project.
Thank you very much. What I was wondering on my side, and I don't know if the panelist or someone in the room want to answer, but for me in Europe, the WETSUS configuration with companies that are providing are committing to develop technologies with the institute is and this system to group the money is quite unique in our European ecosystem. I don't know if you have some similarities or system that is also connecting companies with universities to specifically develop solution for their problem.
I would say it's happening. It's not like that. It's not at all exists, but it's a very minute or say very minimal level. It's not yet say reached to that kind of say maturation level where the strategic initiatives from industry with respect to develop R&D perspective is taking up with various institutions, but it's already started with some of the big business houses.
Okay. If I may, Peter, what was the aim that pushed to produce the WETSUS in Europe? Because apparently, so the situation in India, the companies are quite happy to participate to innovation and to push forward this research. What was the hurdle you tried to overcome with this system?
Thank you. Yeah, the main hurdle was in the region that there were SMEs, but they were not able to get new technologies on a continuous basis because there was no local university present. Maybe an interesting company to mention is the company PAC. They're the global leader in industrial wastewater treatment in anaerobic solutions. They were developed in the 70s when a professor in Wageningen University, Lettinga, first discovered anaerobic wastewater, anaerobic treatment of water. So that was the first technology brought into the region. Several other companies like that were formed, and then around the year 2000, it was the regional government that saw unique advantage in specializing in water. And that is when this specialization started. And the directors that we have at the Institute used to work for PAC, for this regional SME that now has been scaled to no longer small, but medium-sized. And from there, we've been able to gather different funding sources, which are from the local government, the city, the region, the province, and national government. And on top of that, we've been able to get European co-funding through projects. And what is unique is that we did not start with large corporations. If you see in the Netherlands, an equivalent used to be around Philips, but then Philips was the one more or less in control of the ecosystem. In France, you saw comparable ecosystems being set up by the large corporates, such as Suez, Veolia, and also the large water company there. Within those ecosystems, you usually have a very big shark, and the big shark allows small fish to grow around it, but then as soon as they're good, they will eat them. So this is the usual way of initiating these ecosystems. And I think that's also what was mentioned just in India. If big companies do this, then usually you get more of the same. Whereas if you are able to manage this ecosystem that the small companies are more in control, you actually get more breakthrough innovations. So we were able to make sure that the large corporations that are very much in our innovation ecosystem have only the same rights as the small ones, although they need to pay more. In this way, we're able to make sure that the SMEs survive and that they are still working on the breakthrough innovations that they would like, and that there's a direct trust between them. We think that these are the keys for such success. And hopefully that mindset and that logic could also apply in other cultures and hopefully also in India. But I look forward to views on that.
Okay, thank you very much. I think I will now. I think we have to close the session. Or Tanya, you had a question? No. We can have a yes. You are.
Well, thank you very much, Bertrand and panelists. I think that was a very good session, confirm a little bit what we heard already from the presentation of the technologies, although we didn't get to speak about the technologies itself that we presented, but that is also the format. It's partly remote, partly in person. But coming back to the 7 projects and the technologies that were pitched for, I was wondering, I saw, for example, in the presentation of Gies that you have also possibility in a platform to showcase the technologies. So maybe that could be a possibility that could the more you create awareness about your technology, and I think that is better, that is useful. And so maybe that is one option. The other option, which I think was very useful, is also to hear about the importance of understanding each other's ecosystem. And there are various ways of getting in, but we would be more in the mode of getting in via a small company. And then I was wondering how easy it is in that case you need a partner. And how do you find that partner and that right partner? So maybe we should also think a bit ourselves about the water ecosystem, because we do say it's very difficult to enter into the Indian market, but I mean, I'm not the advocate of India, but presumably it's very difficult. It's not that easy either to enter into the European market with the different regulations and going from one member state to another or to the African market. So maybe understanding the ecosystem it could be a better way of approaching that.
Yes, I think you're right. This is a bit what I wanted to say also when after the presentation of Laura. But when I identified the hurdles that are a bit the same, the language, the difference of the regulation. But I think we're not so different in our way of doing things. So there are a lot of things to do together. Any final words,
Thank you, Berto, and thank you, Tanya, for indicating like how we can further take it up. So means the very initial idea when I see the celestial system, which is now we all are interacting, it is like more academicians, research, and means EU is there and few other people, but a future event in which all the 7 projects are showcasing the technologies to Jal Nigam, Jal Sansthan, Public Health Department, because they are the people in the state government, those who develop the terms and condition of the tender. They should know like what kind of technology is available. Like there was, Ma'am Sujatra was presenting on the biodigester and then the interception and diversion. So people think that, okay, there is a no solution to this thing. So this specification never enter into the tender document. And as a result, tender documents are produced with a very special, with a very general condition. So specifications are missing. So if we could organize an event or a pitching into the real industries and to the implementers, so that they are aware like these solutions are available in the market and they could be applied on these scale. And the wonderful thing is like already there are successful pilots within these projects. So yeah.
Yeah, thank you very much. Praveen, last comment. No, it should.
Hello.
Yeah.
Yeah. So the one thing is about the legislation that needs to be in place, no doubt about that. But at the same time, to be get accepted by market is what the key issue over here. And I think to make it suitable for the emerging country like India is what the company should look upon. And sometimes for any developing countries, the growth story is always been, say, a difficult task of balancing the advancement and the investment. So what is required for that particular geography is what I would say is essential for each technology, and modification into that so that it can get easily acceptable with respect to performance perspective as well as the commercial perspective.
Yeah, thank you very much. I think this is what we try to also do with the project together. From online, any last comments, Peter or sorry, Kudli, sorry.
Maybe to add that already in Europe, where maybe prices are even better, it's already a challenge to get new innovations into the market. So when some of our SMEs are actively talking to counterparts in India, they usually get the reply that the counterpart is interested not to buy one of their innovations, but already 1,000. But then the side note is that the offering price that they have in Europe, let's say the unit cost is 1,000, then they're willing to pay 100. So the market is way bigger, but the willingness or the ability to pay is much smaller. I think that poses significant questions by itself, and so where SMEs already struggle to get products into the European market, I'm also convinced that it won't be easy to do it in the Indian market. At the same time, we all see that the issues around water are increasing, and the need to find solutions and implement them are also increasing. So hopefully in both continents, the market conditions and technologies that we together offer improve so that we can actually tackle this very important topic that is of global importance. Thank you.
Thank you. Kuldeep, final remark? You're muted, sorry.
Hello. Yes, sir. The adaptability of products or technology for overseas technology are also used in Indian markets. So there is no, I think, there is no gap in EU market or this Indian market. So we are very much open, or the Indian market is water sector is also using very costly technologies from overseas countries. So, but the specification and the technology adoption is very much easy. So the person, I don't know who is telling that, the PHEs, Public Health Department, Sansthans and Jal Nigams are collaborated for this new technology, or the EU products will definitely help it out. to get into the Indian market for overseas companies and Indian companies to give the technologies or products to overseas market. So that's it from our side.
Thank you very much. So I want to thank all the panelists online and on the scene for their participation. Thank you for having participating to this session. And we can move to our lunch now. Thank you.
Thank you.
We'll be back at 2:30.
This is the third session of the day, and it is about stock taking on market access opportunities and challenges of those technologies that are developed under this India-EU partnership. And we have today my co-chair, Tania Fredericks, then Dr. Manish Diwan, Head Strategic Partnership and Entrepreneurship Development. Then from EU, Dr. Batan Valet, Policy Officer. Then Dr. Praveen Kumar Somasundaram from DST. And we have one virtual online member, Mr. Sanmit Ahuja, who is expert member C Ganga. So friends, before I talk about a bit of the opportunities and challenges that India can provide for these technologies that are developed for water and sanitation sectors, I would like to talk a bit about a bit of technology and innovations, which way actually India perceives them and how we evaluate them being at the government level. Because I have been associated with West Wealth Mission, so and as well as Jal Jeevan Mission also. So when you talk about any technology, definitely the first priority that we see in any technology is the technology that should provide a reliable and consistent performance that meet the expectation and market needs. Because we are talking about the market needs and market uptake. And the market awareness and promotion is also an important step to drive this uptake. So apart from these 2 points, there are a few things actually when we see in technology for evaluation, we followed certain principles and parameters that are evaluated. We call it assured metrics that Government of India follows, that has followed for Jal Jeevan Mission also. Which I am chairing as technical unit head, and there we are evaluating technologies and innovations as well as R&D proposals for water, drinking water and sanitation sectors. So there we always see assured means A for affordability, S for scalability, then S for sustainability. So definitely we look after the look for the sustainability issues in this. Then U for universality or universal application. R for repeatability of the results, then E for environmental aspects that are considered through this. Because when you talk about some technology, you talk about what about the rejects, what are that are coming out of this. So are you taking care of those things, or again they are polluting the environment? And the most important is distinctness, how it is different from the already available in the market. What are the unique selling points people have presented, as well as the pain points that was taken care of maybe. So when I talk about these things, we always look for these parameters in evaluating many technologies. Let me talk about a bit of India's opportunity that we provide. As you know, India is the 5th largest economy and in the world, and India's growing economy presents numerous opportunities for new technology across various sectors, not only drinking water and sanitation. And one important aspect is India's digital penetration provides a large and diverse market for various products and services. And I could see through your presentations, you have touched upon many things in the digital technologies, in your innovations, in your products. And if I talk about the government initiative, yes, we have been talking about this, some of the experts, as well as some of the members sitting in this room. They talk about the Jal Jeevan Mission also. They talk about people online also. Amrit 2.0, then I said, smart city mission, then West Wealth Mission from Government of India at the Office of the Principal Scientific Advisor, then Mahua, Minister of Housing and Rural Housing and Rural Development MoHUA means Ministry of Housing and Urban Affairs. And in this, because why I am taking these names, because as I mentioned, one is Jal Jeevan Mission, where we are also evaluating technologies. Similarly, through our Waste to Wealth Mission also, we are evaluating technologies. And these technologies that are evaluated, they will be listed in the MoHUA portal as well as the portal of the Government of India. It is a two-stage verification process where they are evaluated. And those listed technology only taken by MoHUA to the states as well as urban local bodies, municipal. Now, the thing is that when this technology are not evaluated, because somebody in the previous session also talked about, okay, evaluated technology only be shortlisted and ready for the tendering process by the state government. So state government will also get and notified about those technologies. Similar way what we did for Jal Jeevan Mission also, because those innovations or technologies that are evaluated through Jal Jeevan Mission in a two-stage process, they are only going to the states. States will follow its own tendering process as well as the process they are following acquiring any technology. So yes, another important India is on the process of the urbanizations and creates demand for smart city solutions. So these technologies that are here today, we have witnessed pitching of 7 or 8 technologies. I wish we were more to see, but I didn't know that each projects, they have 3-4 technologies they have already developed. It would have been 2 for each project. It would have been 14 at least. So it would have been easy for us to take the stock of all those technologies and see that how we can provide a platform through the India European Union Trade and Technology Council. Working group 2, that is on green and clean energy technologies. Nevertheless, these are the opportunities that I mentioned. These are some of the missions as well as ministries. They offer opportunities for such kind of technologies. The challenges, actually, what I found, challenges are many, but I will take a few. Of course, one is the price tag. Definitely, we always search for the low-cost technologies and affordability that I mentioned also is important. And second thing, geographic specific technologies, because India having so much variation in the geographical features as well as climate, weather, everything, and soil types and land features, so as well as population density varies from state to state. So technologies that are developed for this through this program, I think they may not always fit to the urban areas. If it is fitting to the urban, maybe the peri-urban, suburban, maybe in the rural areas. So that specificity we need to consider, and that should be one of the selling point. Also, the technologies for urban area, the technology for also for rural areas, because through our missions, also Jal Jeevan Mission, also many other missions, we also target the rural population, and we want to improve the livelihood of the community. And most importantly, the policy as well as regulatory barriers. So these are things, important areas. I think the challenges are many, but Government of India is very keen to actually discuss and develop some of those policies as well as regulatory framework. To take example of that, why I was showing much interest in the sanitation sector, because the biosolids that are generated, and they have the potential for agriculture, they have the potential for, as a nutrition source as well as other sources, but due to we don't have any regulatory framework, or maybe we don't have guidelines for use. So that actually hindering some of the process, because we want to complete the total life cycle process of any technology. Suppose it is for any sanitation sector. So any of the products that are used, that's again, it is coming to the environment. So we have to see that environmental values, and we see the health aspect as well as whether that kind of byproducts or products that are generated, if they have some manual values. Okay, but do you think that are they ready for use in the manner in terms of nutrient, even if they the E. coli content or any other organisms that are harmful to the human being. If the contents are high or beyond certain limits, then probably that doesn't fit to with the whole process. That's why some of the technologies, and they're dumping actually after this, because that's the reason why we are trying now to develop the standards for biosolids in India so that they can be marketed as well as used by communities as well as various organizations. So that's all actually I want to share with you in terms of challenges and opportunities that India provides and the present situation in the country. Now I request my co-chair, Dr. Tanya Fredericks, to take the proceeding further. Thank you.
Thank you very much, Mohanty, for these parameters. You summarized and parameters. I think they're particularly useful if we consider future cooperation. What we have to take into account, affordability for sure. I think I don't think we are at session 3. We are at the end of the way from the lab to the market. We will focus particularly now on, we know that there is technologies there, some have already partners, some still, but none have really been rolled out. And we have to be fair, all may need or want to learn or see which more support we can offer. And that is the main purpose of the session now. And I'm very pleased to start this session with Manish Diwan from Barak. Hello, Manish, long time no see. And we're really looking forward, and we're very happy that you're part of this session this afternoon. It's the arm of DBT that precisely looks at what we Commission tried to do only recently, and that is to help these technologies that are mature from the research and innovation to scale them up and see what is necessary to the market. So thank you very much for being with us, and we're looking forward to your presentation. Before that, let me excuse Mr. Rishi Srivarasta from the Water Commission, although he was supposed to attend virtual, he mentioned that he couldn't make it, but let's go straight to the point with Manish. Thank you.
Thank you, Tanya, and thank you, Forum, for having me here. I think water remains a perennial, most important element for the civilization and humankind. I was incidentally last week visiting Gujarat. There is a place called Dholavira, where Harappan civilization remains have been found. It's a 262-acre area that has been recovered for that civilization. So I was told that how the civilization tried to manage water sources with the wells created at several different heights so that rainwater gets collected and it gets filtered, moves to another chamber. There were 16 chambers like that. How the water is being recycled after utilization. And then the purification, then recycling. And also I was told that the civilization itself got affected by the presence of water and decontamination in the long run. That's a speculation. So the point I was trying to relate to, this important element still remains an unmet need for all of us for various reasons. So BIRAC is a body which I represent, Biotechnology Industry Research Assistance Council, which is an arm of Department of Biotechnology under Science and Technology Ministry that facilitates innovations, knowledge dissemination that gets generated in the typically academic settings, help the translational activities to move towards commercialization and get into the market. I lead the Startup India for biotechnology for that matter. For example, for textile tannery effluents, which get into the circulation in the mainstream water. So we, through the biotechnology innovations, we help and facilitate or enable solutions for both effluent treatment, for example, using biotechnology solutions like enzymatic solutions or biophysical solutions, and also help facilitate newer innovations to replace such chemical dyes with biopigments, for instance, or enzymatic degradation handling of tannery. For that, what we do is we facilitate innovators across the country. That includes academia, startups, industries. So at present, there are about 7,000 plus startups that have been supported by BIRAD. We fund them and throughout their technology readiness level from TRL1 to TRL9. We have also created a network of incubation centers where such innovators can reach out and utilize common access facilities so that their innovations can move from for commercialization from TRL1 to TRL5 or so. Being a central government entity, we also enable networking and connecting the opportunities with various enabling stakeholders. This is done through public-private partnership, and there is grant in aid at the initial stage, which is being provided, followed by equity-linked funding instruments, and encouraging private investment and private capital to move into the biotech innovation ecosystem. And over a period of time, we have been able to see a large influx, which has helped create India's startup innovation ecosystem to attain a height. I think some of the innovations I would mention that have been able to reach from initial stage of ideation to a level of field validation, and some of them have also enhanced their stakes to reach to manufacturing and deployment level. And I think this is a very small glimpse. I was not aware what specific examples or technologies being discussed, which are funded combinedly by EU and India. But I think that's a sampler which I think we can relate to. And if there are opportunities or requirements that they need to move into commercial deployment, Government of India funding through BIRAC as an enabler, that is available, and all those opportunities also become enabler. The unmet need for that area is very diverse and large. As I mentioned, effluent treatment, waste to value, to, for example, water for dialysis that is imported for India's requirement at such a large scale. So solutions like that are also relevant and important for that matter. Waste to value, for example, municipal waste segregation and utilizing that waste for with anaerobic digestion using enzyme yields both biogas, biomass, as well as purification of water for secondary purposes. So Revi Technologies is one solution which has received support from BIRAC, and now they have been able to set up their own manufacturing facility for taking this activity forward. Another example is the open water innovations, which has been recognized at international forums like Slush, for example, as top 50 innovations. They've been able to, they've tested their technology both for ground level water as well as domestic water. And they have done the field validations too. MicroGo is another example of such innovation, which has now reached a status where railways, Indian railways have given them contract to run one of the regional railways operation for providing drinking water. Then there are other examples also in which have reached to a stage that have been able to raise follow-on funding from private investors and have been able to deploy their solution at some scale. But I think India being a very large geography, very diverse and high unmet need areas. So these are only handful of some successful examples. There are a few things that still remains unmet, and we need to kind of enhance the support from the central enablers perspective. There are we need, if strategically European Union and India come together and consider that the technologies which evolve from academic setting or incubation center, they typically do not reach beyond TRL 3 to TRL 5. So for technology maturation and enhancement of their competitiveness so that they can be tested in real life setting, for instance, common access facilities which allow piloting and further down piloting to manufacturing scale. I think that is a common access infrastructure is still a gap, large gap in the country. The second gap that is seen is as a government enabler, we have limited resources and those can only be deployed to a certain extent. I think the model, the public-private partnership and joint integration with, let's say, at regional levels, that enhances the scope of bringing together stakeholders that can upsize such resources capacities and open up new opportunities for larger scale deployment. If particular solution is being able to work in one geography, there's a good probability that might be helpful for utilization elsewhere as well. So I think such integration of resources catalyzed by relevant stakeholders can go a long way. Thirdly, and the last, which also becomes a relevant point here, is that many such solutions are dependent on public procurement or public bodies' recognition. For instance, water supplies are governed by.
Sorry, Manish, one more minute because we need maybe some questions and answers, and we have a number of other persons.
Yeah, I'm just finishing.
You
That's the last
to
point.
finish. Yes. Okay.
Yeah.
Go
So just like we mentioned about Jal Board, which is responsible for supply of water and resources. So unless a solution gets recognized and integrated at that level for facilitation, such large-scale deployments remains a challenge. So I think as enablers of the ecosystem, those 3-4 points became are important, and if more people get integrated through efforts like this, that would be helpful. I'll stop here. Thank you.
Thank you very much. Any questions from the audience? No. Yes, sorry. Thank you very much, Manish, for this overview and reaching out to people here. And any questions from the audience on what BIRAC could do? I can't see Vivek. Anybody in the chat? No? Then one time, two times, three times? No? Then, yeah, well, Samrat, do you see any questions from handwrite or chat?
Yes. There is a question to Dr. Manish. And it's Dr. Manish, just wondering, what is the range of support that can be expected from IRAC? Question.
So if it is in terms of funding support, so we have been able to give about 10.5 crore as maximum funding to one startup in regular schemes. There is one scheme where where industry has to pitch in 50% of the total funding. Under that, there is no cap. For example, for COVID vaccines, for instance, we had supported much larger amount. For other capacity buildings, it runs in several $1 million.
That is it. So then I have the pleasure, honor to ask my colleague, Bertrand Vallet, to show what we have also considered as needed to look more at this market uptake at the European Commission level. Experiences built upon our prior cooperation on research and innovation, not only with India, of course, but mainly within the Union, but per definition, all the cooperation that we are doing within our research and innovation framework program, Horizon 2020 and now Horizon Europe. It's the biggest program in the world and open to the world. And based on that, we could gather a lot of information, lessons learned. And one lesson that we have learned is that we have too much technology in the shelves. And Bertrand is going to guide us and encourage you and help us to how not that happening, right?
Yes, exactly. Thank you very much, Tanya. We'll just wait. Yes. Okay. So indeed, what I will present today is a bit the actions that we have in the program for to support market uptake for innovative solutions. So there are various instruments. Yeah. I will sorry for that. Presentation mode. And then you can switch display on the top. Yeah. Yeah. We will come. We will arrive. I can in the meantime I can do the introduction. I will pass by the so we have different type of products. We have I will present what is called a pre-commercial procurement. We were talking about procurement and issues with procurement earlier today. And I think these are instruments that may be able to come over these issues. We also have product procurement for innovative solutions. I will present also an example related to the water topic because it's important to see a bit what is happening in the sector. And two other things that are the European Innovation Council that help SMEs and startups to be funded. Okay, perfect. That's good. Now, is it?